Hello. So hi guys, we have some small technical issues. We have to change the live on YouTube. We have to open a YouTube live called Paper Sessions. The StreamYard like just closed. So for the authors, we will send through EasyChair the new link, and I'll send them for through EasyChair for the next sessions. And the authors on those chairs were already informed through the previous link, but I'll send it away. Okay. So sorry for this small delay. We would like to invite the first papers of this session, starting with the first paper of the conference. First of all, thank you very much for being here. Enhanced semantic understanding command and control ontological approach for message enrichment. Remembering, he'll do his presentation for 10 minutes and then all the other presentations. We won't stop for questioning all the questions of the session at the end. So write down your questions to the end of the session. Thank you.
Hello everyone, it's great to be here at this important conference, the Latin American Workshop Formation Fusion. Thank you very much for joining. Today is November 23rd, 2020. My name is Flavio Ferreira, I'm from Brazil, and I am PhD student in computer science at College Militar Institute of Engineer. Also, I work as a software engineer at the company in Brazil. Before to start my presentation, I want to thank my two advisors, Duarte and Claudia, for support that they have given to now. I want to thank to the chair of this conference, Paulo Costa and Claudio Michele, and in their names, I want to extend my thanks to all the revisors and the staff, because I know how important it is happy to make a conference like it. So, now I'm going to talk about my new paper, called Enrichment Semantic Understanding in Command Control, an ontological approach for message reading. My presentation is divided in 4 sections. First, I want to talk about the introduction, because I think it is important to show how the textual messages are extended in command control. Second, I will describe about a few more important concepts that I will handle here. After that, I'm going to explain the Machado ontology is the main section of this presentation. For the next, I finish my presentation with my conclusions and talk about a little the future works. So, there are many situations that can lead the military operation to fail. And I will show you 3 situations that I want to highlight here. The first situation I want to highlight is the way how the textual messages are understood by agents can lead the military operation to success or not. It's because if the agent understands the message wrong, they can pass wrong information to the commander, and the commander can make your decision with this wrong information. The second situation I want to highlight is the large number of the textual message extended in military operation can make reading impossible for the agents. And the last situation I want to highlight is classify the textual message as priority or not, maybe link it with the experience of the agent. Therefore, if the agent have a little work experience, they can classify the message wrong. So, even if the agent have a lot of work experience and they can read the message quickly, doubts can arise because of the several factors, such as grammar error, absence word, trouble semantics, etc. Faced with this problem, I think it is important to the agent to have some resource that will increase the chance they understand the message better. Therefore, I think it is possible to improve the understanding of the textual message with the use of the natural language processing. But before use it, I think it is necessary to understand what are the elements and how they related in a domain of information. One of the way to find out the elements and understand your related with the use of the ontology. Ontology has been applied in several domains of the information. This work's goal is to propose a conceptual model to describe knowledge of the textual message extended in command control. And now I will describe some concepts I think it is important to show here. The first concept is command control. Command control is the way how the commander gets information about military operation and he can make his decision with it. Also, command control allows the commander to know how the military operation is going. The second concept is ontology. Ontology is a formal specification about sorts of the objects, properties, and relations that are possible to specify a domain of knowledge. Ontology provides structured vocabulary for describing knowledge about a given domain. And it is abstract model of the world that you desire to represent. The third concept is natural language process. Natural language process, also called NLP, is the field of the artificial intelligence that is used to train the computer to understand the language human. Also, natural language process is a branch of the AI that uses the algorithm to handle tests receiving like input and processing results like output. The last concept is semantic interoperability. Semantic interoperability is ability the two or more systems or components extend information and use it. Also, semantic interoperability is how the system can extend information with another system using semantics and syntax. Now, I'm going to talk about the mais C2 ontology. Mais C2 ontology is a term em português and it is mean modelo para apoiar a interoperabilidade semântica em comando e controle. But if you want to translate this term to English, it means model to support semantic interoperability in command control. This ontology was created to improve the understanding of the agent when they need to read the textual message extended in command control environment. To read it, we propose a domain ontology to understand what are the elements and how then are related. This model was divided into parts called Block A and Block B. Block A and Block B. That division doesn't influence the syntax of this model. It is just to improve the understanding it. Now I'm going to talk about the Block A. The Block A is the main part of this model because it is to show how the text are extended in command control. And these agents called high command unit and low command unit, and both elements are units. The idea here is to show how the textual messages are extended between them. There is an element communication that materializes this relation between high command unit and low command unit, and it is connection point between block A and block B. These agents, high command units and low command units, can assume the role of the sender and the receiver. It is possible because in a situation they have intention to send, in another situation they have ability to receive. Now I'm going to talk about the block B. The block B represents part of this model where the messages are processed. How I said, the communication element is the connection point in between block A and block B. This block has two parts. The first part represents how the textual messages are processed, and how it can be classified as priority or not. The second part of this model represents how the elements are categorized like an name entities in command control. To improve the understanding of the textual message and to help the agent read it, we create 5 categories of the name entities in command control. These categories are place, action, military unit, equipment, agent, and direction. Place category represents a place where the military operation happens. Action category represents an action the agent have to do when the commander sends the message to them. Military unit category represents a group of the military people in a military operation. Equipment category represents any object used in a military operation. Agent category represents a person that has a responsibility in a military operation, and the direction category represents a direction that the agents have to follow in a military operation. Now I will finish my presentation with my conclusions and the future works. This paper addresses many problems in a textual message extended in command control. But if the agent have resources to help understand the textual message better, I think that my C2 ontology can be a great contribution to reach it. My C2 ontology provides definition for knowledge of the name entity in command control, and it provides a model to classify the textual message like priority or not. This ontology was built into Army in Brazil, but this model can be extended to another military domain or non-military domain, such as floods, tornadoes, disasters, etc. We build this ontology as a first step towards improving the textual message extended in command control environment. How the future works, we intend to go deeper into the Machado ontology to understand this domain better and to find out other resources that can help to improve the understanding of the textual message in command control. Thank you very much for the kind attention.
Thank you very much. As Claudia mentioned, we are going to go over the papers and we'll leave the Q&A to the end. So the next speaker, please. It's online, right?
Hello everyone, I'm Leopoldo, Lusquino from São Paulo State University, and now I will present our work entitled Time Series Forecasting with Weightless Neural Network. And this work was developed in a context that we need to develop some machine learning model to perform short-term forecasting when we had so few data available. And during this presentation, I will explain Barrage's motivation and can you hear me? During this presentation, I will explain Barrage's motivation. I will introducing the weightless model that we used to perform this strategy. and I will show our first experimental results in different data sets, and I will show how we intend to extend this work. And this strategy was started to be elaborated during the pandemic of COVID, because when the pandemic, in the very beginning of the pandemic, we had so few data available about the spread of the pandemic, and we need to forecasting the evolution of the pandemic in different parts of the Rio de Janeiro city. And during this time, we don't have similar analogous data sets that we can use for perform some kind of transfer learning, because the spread and the evolution of the spread of the pandemic is so different of the evolution of another epidemics and pandemics. And because of this, different state-of-the-art models, for example, recurrent neural networks, were in disadvantage during this time, because they are so much they're consuming in order that to perform a good generalization. And in this time, in the same year, a seminal paper in green machine learning was released, this tackle climate change with machine learning. And this paper established the guidelines to development of the machine learning models. And in this paper is proved, is showed that time series forecasting and time series analysis is one of the most valuable machine learning tasks in order to mitigate carbon emission. And because of this, we already started to thinking about how to develop a green machine learning model that was able to perform time series forecasting, especially in the cases that we have a short-term horizon of the prediction and we have few data available. And because of this, we start to try to implement weightless neural network for this kind of task, because there's a lot of evidence in literature that weightless neural network can achieve a good generalization in specific scenarios when we have few data available, because this kind of model have a good VC dimension. And despite of this, is not best model for capturing, for example, complex correlationships or high representation of the features. Each can achieve a good generalization in this case when have few data available, and we don't have, for example, so much patterns of seasonality available. And for this strategy, we started to try to implement this strategy employing this specific model, regression wizard. This is a weightless neural network based on one tuple classifier. Because of this, training in this model is just related to write-on memory, and making inference in this kind of model is just related to read the content of the accessed memory locations. And regression wizard, specifically using a topology based on run nodes, it's very low time consuming, very low resource consuming. And this specific model have two fields by memory location. One is the access counter, and another is the partial sum. And during the training, this model needs binary input, and it uses a pseudo-random map to map the bits of this binary word in order to compose the address of the memory locations and the run nodes. One time that one memory location is accessed, this access counter is summed, and the associated targets, the independent variable associated to this binary word, associated to the input, is used to increment the partial sum. And the training just constant in this. There is no kind of weight calibration, this kind of things here. And during the prediction, we just access the specific memory locations and perform a simple average or another kind of average that we prefer. And due to the topology of the model, it can approximate a kernel regression. It would make a non-parametric regression using just this simple topology and this simple strategy. And regression wizard was be released 1 year before the pandemic. And it's achieved in different data sets a good performance for prediction, for simple prediction with few data. And because of this, we think in apply this on the specific pipeline to perform short-term forecasting. Firstly, we take the time series and apply a moving average in GIS in order to smooth the noise, in order to reduce the fluctuations of the data. After GIS, we apply in a slide window that basically gets a specific amount of data as input, and we apply and use and correlate GIS with the next point, the point ahead, that is the point that we want to forecasting. And this slide window basically gets a specific amount of data that is the window that you use to perform the forecasting, and maps GIS on a lag structure, very similar to the auto-regressive lag structure. And after this, as I said, it's necessary that this kind of model consumes binary words, binary data, and because of this, we apply a binarization technique. And here in this work, and the pre-processing technique that we use to perform this binarization were different thermometers, but our best thermometer here was a circular thermometer. And after this, we give this data in order that regression wizard can be trained using this data. And the inference process is the same, but we perform prediction in the last step. And here we can see a very simple example how this pipeline works. And in order to make a benchmark to validate, to evaluate our strategy, we applied regression wizard in this pipeline in 3 different data sets. The real data set of the COVID on the first month of the spread of the pandemic on Rio de Janeiro. One famous data set consolidated on literature that have field data about temperatures in Melbourne, and one synthetic data that we produced using the same distribution of the data of the COVID and using field data, because our original reason or original motivation here is producing good short-term forecasting with field data available. And in this benchmark, we applied more 2 models in order to compare our model with state-of-the-art models. And here we applied ARIMA, one of the most famous auto-regressive models for perform time series forecasting. And in general, this model have good performance in data that have linear behavior and property. It's a very famous model produced by Facebook that have the good capacity to capture seasonality on the data. And basically, all of these experiments were publicly available, and the hyperparameter choice is available on the description of the experiments, and the experiments are available on a repository that is related on the procedures of the La Fusion. And I will not talk more about the hyperparameter choice here, but here we can see the results of the benchmark. We use the 3 different eurometrics, and here we can see the inference time. And our model outperformed the another 2 models in the temperature and the synthetic data set. And we outperformed profit in this data set, in COVID data set, but we was underperformed by ARIMA. But we stay competitive with ARIMA in this data set. But in the inference time, our model outperforms the another models in all scenarios and with great advantage. And here we can see the stability of the models. That is the capacity of the model to produce good results or to get a fast convergence when the hyperparameters of the models are changed. And here you can see the stability of the models for COVID data sets, for temperature data sets, and for synthetic data sets. In your case, that we need to produce green AI model, we need to develop a model that is not so dependent of the hyperparameter models, because if we have a model with fast inference, fast training, but it's dependent of many cases of hyperparameter tests in order to get a good setup, we will consume energy, we will produce carbon emission the same way. And because of this, stability of the model is very important for us, and this result shows that our model is low sensitive to hyperparameter choice. The topology of the model in general is sufficient to guarantee that we have a good performance. And our conclusion is that for in a specific case that we start to make these experiments to produce this strategy in COVID spread in the beginning of the COVID spread, Lima achieved the best error metrics, but our model was so competitive with this. But our model outperformed the other models in other cases, in other data sets, and in all scenarios, our solution achieved the best memory uses and the best inference and training time. And our current work or future work, including try to implement this strategy in using ensemble learning, because regression wizard is so time consuming and it's consuming few computational resources, and it's very nice to be used in embedded systems. And because of this, we are trying to make some ensemble learning and federated learning strategies using this same approach. And we are trying now to employ this strategy to produce multi-step ahead forecast, and we are comparing this with transformers and recurrent neural networks and our models that are state of the art now. And lastly, we are trying to combine this with autoregressive strategies, and including with deep neural networks in employing meta learning, in order that when we need to capture, for example, high presentation of the data, we can use a more robust model in order to produce the best forecast. But when weightless neural network is sufficient to get a good performance in forecast, we employ this. And because of this, we are trying to produce this kind of hybrid model, combining autoregressive model or solution and state-of-the-art solution employing a recurrent neural network. And we are so convinced that it's one great way to develop best solutions for embedded systems that are used for forecasting now. And that is, thanks so much.
Hello, good morning. Okay. My name is Brian Gutierrez. I am junior researcher at the Sena. I'm going to present a unit adapted architecture for sugar research segmentation in Colombian mills. Okay. The introduction. The sugar production from some sugarcane is complex process that require careful tracking of crystals ground to make sure the grains are of good quality and the crystallization process is working well, thus having accurate and effective crystallographic analysis is very important of the Colombian production process. The sugarcane mills focus on detecting the location and shape of each crystal in process image, retard that classifying photographs. Artificial intelligent techniques. Indeed, various solutions, ranging from patent technologies to numerous published papers, have been proposed to address this usage. However, the software solutions available are often impractical for Colombian sugar mills due to their invasive nature and high cost. Um, on the other hand, many research papers rely on photographs taken under controlled conditions, which may not be feasible in real-world scenarios. In Colombia, of sample are careful taken under a microscope and then manually processed for further analysis with traditional machine vision software solutions, which are insufficient as they can detect all crystals and generating incomplete and inaccurate results. This leads to discrepancies in essential calculation such as crystal size and coefficients of variation of uh, to address these inaccuracies. This research project focused on implementing the unit deep learning model for sugar crystal segmentation. For this purpose, unlike previous under control conditions, this study used taken from in real world conditions. Yeah. The methodology is therefore this paper concentrated on constructing foreground segmentation and generating prediction for crystal max from image captured during in Colombian sugar mills. Additionally, reader through the typical workflow of machine learning projects. And data collection, a total of 400 photographs were collected for this study, out of which 156 were provided by a Colombian sugar factory during its crystallization process and have a resolution of 2048 by 1530 pixels. The remaining 244 images were supplied by the Colombian sugarcane research institute with a resolution of 2808 by 2048 pixels from sample taken from June. The 400 images were manually labeled using the open source tool. tool BGG annotator. This tool alone used to generate JSON files contain the coordinates of the crystal present in each photo, and subsequently these coordinates were used to create individual maps for the crystal as the deficit in the image to data was course drop and this generate the data with new image offering the model with range of sugar crystal examples. This is important to improve the model performance and ability to work with different image. After the process, a total 1,200 images were obtained. Okay, here are some photos from the manual labeling process. Okay. For the model, the standardized the input format for the segmentation model, the Garrett image were resized to 512 by 512 pixels and convert into tensors with no other processor performed. For the segmentation tags, the unit architecture was adopted. This deep convolution neuronal network is renowned for its effectiveness and semantic segmentation. The choice of the unit design was based on its capability to capture both local and global features, making it particularly suitable for accurately Euler irregularly shaped sugar crystals. The employee model followed in decoder framework with this extruded. The encoder component employs a convolutional layer and downsampling operation to extract pertinent errors from the input image. Thereby facilitating effective Fourier extraction. On the other hand, the decoder module, which include upsampling and skill connection works to reconstruct spatial segmentation outcomes. The initial set of 1,200 images was split into three portions. 70% was the aside for training, while 10% was allocated for both validation and testing, respectively. As a result, 840 images were randomly chosen to full the model training process. 240 images were used to gauge the evaluate of. Finally, 120 images were subject to rigorous testing. The training process unfolded over 20 epochs during which the unit network learned to distinguish and segmentation sugar crystal with the image. The training and validation costs gradually decreased with each epoch. The initial high training cost of 0.2156 decreased to a lower value 0.317 by the 20 epoch, indicating that the model effective to minimize the difference between prediction and ground truth. Similarly, the validation cost decreased from 0.0957 to 0.0364, reflecting the model ability to generalize the easy understanding to unsend data. During the model evaluation process, 2 key metrics were employed as benchmark accuracy and insertion over unit. The training process unfolded over 20 epochs, during with the unit network learned to distinguish segment sugar crystal within the image. The training accuracy standard at the 0.9001 and standard increasing to 0.987 for showcasing the model's ability to correctly classify pixel as sugar crystal. The validation accuracy follow as a similar trend, increasing from 0.9631 to 0.9864. This signifies that the model was able to generate its learning through the validation sets. Yield impressive segmentation results. The insertion over unit is a crucial metric for segmentation tasks, reflecting the overlap between predict and grow through segments. IOU values increased progressively, starting from 0.5577 and reached a peak of 0.8240. This indicates that the model improved in accurately identify and delineate sugar crystal in the image. The increasing IOU values suggests that the model learning to align its prediction more closely with the actual boundaries of the crystal. These are results. This is a max prediction max under the image originals. Yeah, have a validation accuracy of 98.6% and training 98.7%. The conclusion, yeah, the future world, and that's the preprocessing of images to optimize the workflow and explore advanced segmentation techniques tailored to the specific requirements of Colombian sugar mills, considering the various shapes present in the crystal, yeah, and conduct a thorough comparison of the unit model's performance against other state-of-the-art segmentation models. And thank you very much.
Thank you very much. Our next speaker is in person. Hello, Wendy.
Okay, okay. Got it. Okay. Great. Slides. Okay, so I'm going to present what I'm doing with National Institute of Technology and the Institute of Psychiatry from Federal University of Rio de Janeiro, which is predicting mild cognitive impairment, integrating cognitive and motor features from machine learning. So some of the context, we will talk about the background for our research, the materials, the methods, the results, and next steps. Okay, so for our background, what is mild cognitive impairment? Mild cognitive impairment is a transitional stage between dementia and a healthy patient. Okay, and it's super important to have an early diagnosis so we can slow down the progression to the dementia. Okay. So what are our challenges? Our challenges in machine learning for this field is to make an affordable model, okay? Because image data is being used from the researchers, but image data it's kind of costly, okay? Because to generate image data, we need to do exams such as resonance, and this requires qualified professionals. And we know that in Brazil, the reality of some people is that we cannot afford such exams. And image data are generating the best results for this kind of field, for machine learning with this prediction, but we wanted to generate a more accessible method, okay? And some new researchers are going in this way to generate an affordable manner to predict mild cognitive impairment in elderly. Okay, so the loss is not just cognitive, okay? The loss is motor as well. So elderly people with MCI, which is the acronym for mild cognitive impairment. So elderly people with this disease has motor loss as well. And motor responses are already being used as biomarkers for this kind of disease. Okay, and in this context, we present our goal, which is to integrate motor features with cognitive features to build a machine learning model, a classification machine learning model that could accurately predict MCI in an affordable manner. So some of our materials. We have 272 elderly individuals divided in healthy, dementia, and MCI. Okay, we can see that there's this balance, and we treat this as balance in our model, but this is natural. Okay, the data have these problems, but we gather features from 4 points: motor performance, features focusing on motor performance, such as balancing tests, hand grip, which is a test that you use in your hand to see the strength, sit and stand, and some other methods that we will not comment in some details here, but just to generate some examples, okay? But we have also tests that focuses on cognitive performance, which is the mini mental. It's also a well-known test from the Psychiatry Institute, clock draw tests, some other tests for fluence that happen what it is. And some tests that use cognitive and motor performances. We cannot separate because these tests evaluate both of these features, okay? We have some examples for maze test, which is a test of, there is a maze, and you need to think about how do you solve the maze, so you need to use cognitive function and motor functions to solve the maze. And some dual tasks, gate speed test as well, which is gate speed related to another task in the same time, okay? And we use as well some important information such as spelling, and this is super important because we know that here in Brazil, it's not always that the elderly have some cognitive problem, but this scolarity is influencing as well. You know, that some elderly people did not have access to great scolarity, so we need to check that as well. Okay, so for our methods, we first did a data collection, which we gathered some features in these 4 domains that I commented, and the diagnosis for these patients as well. And then we generated a data set called elderly data set with data from all the 3 classes: MCI, dementia, and healthy patients. Then in the machine learning pipeline, we did the pre-processing steps, separate the healthy and MCI, because remember, our model is focusing on predicting the MCI. We applied our prediction model and then did the feature importance. Okay, So for the pre-processing step, we first separate the data between training and tests, 20% and 80%. Then we did data normalization, but we also test our features without data normalization, okay? And then we did data interpretation because there were some missing values. We used mice to do our data interpretation. And just in the end of the processing step, where we separate, we split the patients healthy and MCI. Why? Because we wanted to use the dementia to enhance our model of data imputation. Because with the information of dementia, the data imputation technique, the mice could use the information to imputate data for MCI or for healthy people. So that's why we only do the splitting in the end of the processing step. Okay, for our predicting model. Our predicting model used 3 algorithms: support vector machine, random forest, and extreme gradient boost. Okay, we optimized the hyperparameters with cross-validation and 5 folds. And as I comment, there was a disbalance. So we chose optimization metrics such as F1, F beta 2, and recall because we wanted to minimize the false negatives, aka people that are wrongly classified as healthy and they were with MCI. Okay, so that's why we chose this optimization metrics, and also to compensate our disbalance. Because if you use accuracy, the accuracy would influence on the model, and this disbalance is not great for this kind of optimization. Okay, feature importance. Feature importance was made with Shapley value technique from the game theory, and why it's important to do this step. Because we needed to understand what was the most relevant features, not only to see if the motor features do increase the model, do make the model better, but to see which tests are essential. Because remember, we wanted to create an accessible model. So to create an accessible model, some tests could be cut off if they are not essential to the model. And this is why we needed to do this feature. Okay, for the results. Okay, for the results. The results show that the SVM support vector machine make the best job. You see, Chijibus gradient boost has also made interesting results, but the best job was made by SVM. Okay, and this image also shows that SVM works better when the data was not normalized. Okay, this can happen when the data with the largest scale, the features with the largest scale, contribute to the model in a way that we're not expecting. So this can happen sometimes, and it's shown actually in the Shapley that the value of the larger scale contribute best to the model. So that's why the normalization features make the SVM better in this situation. Okay, so it's better in all the metrics, including F1 precision. This is our confusion matrix. Okay, so in this confusion matrix, we can see that we achieved 88% of sensitivity for MCI, and this is a great result. Okay, so some models with image are achieving 95, but we needed a model that were acceptable, and to do that, we needed to accept some results that are not the best from literature, but could help to early diagnosis. Okay, and we also managed to correctly identify 86% of the health individuals specificity. Okay. For the feature importance, what we noticed that the features that most contribute were the motor and cognitive tests. Okay. But okay, the cognitive is involved as well, and we were expecting that the cognitive tests has a strong influence to detect MCI. But we could see that motor tests are not far behind. So this relationship between motor and cognitive features can be seen here, and we managed to prove that motor tests can be helpful for this kind of prediction. And also, motor tests have some ways to evaluate that is low cost. The tests that I've mentioned are low cost. So that's why this result is super important. Okay, so next steps. We wanted to extend our model to work with dementia patients, but also we want to validate the algorithm with a new group of elderly. So the Institute of Psychiatry are already working to gather more information for more elderly people, so we could validate our model and then put the model into the production, put into the laboratory. We want to know what is the prediction before applying the statistics. So a great thanks, and I wanted just to say that this is my grandma, and she has dementia. So that's why this work is super important to me. When I came to computer engineering, I wanted to do something that changed the world, that could help the world in a good way. So thanks for Andrea, thanks for Manuel for helping me to do that. Thanks you as well to giving me that opportunity. Thanks for Claudia, because this is my grandma. She has dementia, and I wanted that this model could be applied to her, so we could make that early diagnosis and prevent her. But she's healthy, she's well, and she's happy, and that's the good point. Thanks, everyone.
Thank you very much. So we will move to the next. Yes.
Hi, I'd like to ask Maria. I saw some strange results in the forest, the forest test. Do you have any insights why did it happen?
Okay, so random forest doesn't perform well when we do this kind of prediction. And we don't know why this could happen because we tested a lot of parameters. But we've got some interesting results with SVM. And I think this results generated a good amount of accuracy of one and recall for us to be satisfied. Okay, but just to uh, talk a little about our future work, when we do the test of predicting health people and dementia, random forest does a great job, and it's super accurately predicts this between these two classes. Okay, so dementia and healthy people can be done with random forest in a good way, but the MCY we don't know why the random forest didn't get a great result. Okay.
Any other questions? There's one for paper number 1 from Flavio. The Manis C2 ontology. How, whether you use, and if you use, how do you use a reason to make inferences in the ontology?
Yeah. In fact, we were not using the inference engine for the ontology. The ontology is, the idea of the ontology is to represent the communication between two applications in C2 usual software, right? So we have, somebody that wants to communicate with the other, but they are not necessarily using the same software. So the idea of having an ontology is just to uniformize the way they, let's say, represent the data, so we can then analyze or process data. But the idea of having the ontology would uniformize the data and allow this kind of enrichment of the message for any communication application that needs to have that feature.
Thank you for your questions. we will send the questions on YouTube channel to the authors at the end of the event. So, and also you can put you in contact with the emails. So you can also send me the questions and I'll back to the authors also. So thanks a lot for your questioning, thanks a lot for your audience. And I'm now pleased to announce on shared event this past week, La Fusion in past week, is the presentation. We have some issues to share the screen, but then I can do the announcements. So I'd like to introduce and invite Dr. José Brancalhão from Embraer. I've met Brancalhão at the first time in Fusion 2016, and since we have been working together, and we have organized several sessions on Fusion on Industry 4.0, and discussing about topics and organizing tutorials. Brancalhão has made his PhD on ITA, has been in that for the last 15 years, and developed several projects on Embraer, especially on the Guanabara Bay, that we will show some of those things today. And it's a pleasure to have him here. We've been trying to share some PhD students for a while now. We have been we from COP have been at Embraer several times to present our papers there. So students, come on. We want to take you there more often. São Bernardo is close. Just placing those things in the air. Who knows? So I would like to thank you once again. Brancalhão is also our sponsor chair for 2025, him and André Braga. André Braga is also from Embraer. So André, if you are seeing us here, thank you. Happy to have you here. So José, it's yours. Welcome. Thank you very much to be here. And thank you for your support. We are taking care of those things, and let's take a look at what was it. Okay.
Hello, good morning. Thank you, Claudia, for the introduction. Thank you, Paulo. Thank you for inviting me to be here today for this presentation. It's my pleasure to be here to present some ideas, to share some concepts, and to talk about the projects that we have been developing at the Research and Development Department at the Embraer. So thank you very much for your invitation. The title of my presentation today is Innovation and Projects Developed in the Intelligence Systems Department at Embraer. This is the outline of my presentation. I will talk about the innovation process at Embraer, the technological development department, and finally, you will present some projects that we have been developing in the intelligence systems area at Embraer. Well, I will talk a little bit about Embraer and show to you the projects and the developments that we have been developing in the last 20 years. So, first of all, I would like to say that Embraer is one of the largest aerospace conglomerates in the world. It's a leader in the market segments in which it operates. Embraer today is the third largest commercial jets manufacturer in the world. The history of Embraer starts in 1946 when Brazil launches a national strategic aerospace initiative via the Aeronautics Technical Center, CTA, and the Technological Institute of Aeronautics, ITA. So we can say that the history of Embraer started 20 years before the foundation of the company, when the government launches the initiative in the CTA. Because for Embraer to be created, it was necessary to have good people with knowledge and competence to develop the products of the company. So the first initiative was to develop, to create the Institute of Technologies to form, to have people qualified to develop the projects in the company. And in 1969, the federal government creates Embraer to develop and manufacture aircraft in Brazil. Another important mark in our history was in 1994, when Embraer was privatized, fusing technological and industry expertise with an entrepreneurial approach. And now in 2023, Embraer is one of the world's leading manufacturers of commercial and executive jets, with substantial operations in defense and security. In this picture, you can see a lot of products and technologies that Embraer developed in the last 20 years. So we can see that we developed a lot of technologies and products in the last 20 years. But our development is not restricted to development of aircraft or planes. We have other companies, affiliated companies like Visiona, that produces and develop satellites. ATEC, that is a company that develops the aircraft management systems that is being used in Brazil. And we can see a lot of aircraft here, starting with the ERJ-145 until today, when you have the Praetor 500. Another important product that I can show to you, we have a company that produces radars, like the Sentir M20 and the Saber M60 that is being used in CISFROM. That's a program for the surveillance of the Brazilian borders. So we have This rates produced by Embraer and provided to the army, Brazilian army. We have military aircraft as well, like the early warning provided to India for the surveillance of the airspace in India. The KC-390 that's being delivered to a lot of countries in the world. So we have a large portfolio, as you can see here. And we're very proud about this technology and the developments that we made in the last 20 years in the company. Some numbers about Embraer. We have more than 3,500 engineers working in the company. We are present in more than 100 countries. We have more than 20 certified aircraft using state-of-the-art technology. More than 145 million passengers are transported in Embraer aircraft per year. We have more than 8,000 aircraft delivered since the foundation of the company. And every 10 seconds, an Embraer plane takes off in some airport in the world. Today we have about 20,000 employees across the globe. An interesting number here is that we have 1,300 people with master degrees, PhD, and postgraduate people in the company. We have more than 5,900 people dedicated to research and development in the company, and more than 300 engineers dedicated to research and technology in the company. Here, this graph, you can see that innovation is very, very important to Embraer. We can see that around 50% of the revenue from Embraer comes from products and services that were launched until 5 years earlier. So innovation is not a choice or an option for Embraer. It's unnecessary for the future of the company. Innovation is essential for our perpetuity, and is present since our foundation, is in the DNA of the company. But how Embraer decides what will be developed in the what the technologies we will develop in the next years? We use the concept of vertical innovation at the company. Verticals are strategic and priority themes in which Embraer focuses its investments and efforts through innovation. So, based in the strategic plan, in the innovation trends, emerging technologies, technology trends in the aeronautic industry, and the new business, we defined the verticals that are areas that we will be developing competence and technology in the future years. So now we have the verticals listed here. We have the vertical for zero emissions, for autonomous flights, aircraft competitiveness, AI, data science, Industry 4.0, passenger experience, and cybersecurity. These are the main areas that we are developing our competence today. We are developing our innovation products today. talk about the technological development at Embraer. In our development, we consider the technology readiness level. The technology readiness level is a model originally developed by NASA that's used to measure maturity level of technology throughout its research, development, and deployment phase progression. TRLs are based on a scale from 1 to 9, with 9 being the most mature technology. TRLs allow engineers to have a consistent datum of reference for understanding technology evolution regardless of their technical background. Systematic addressing of TRLs is required, allowing the technology to evolve from conception through to research, development, and deployment. So we can see in this picture the main objectives of each level of the TRLs, starting with the TRL 1, when we develop basic research, and then we go to proof of concept in TRL 2 or 3. In the technological development, we are talking about TRL 3 to 6. It's considered that in the technological development, we go to TRL 6 to develop a level of technology that will be transferred to another areas of the company in order to proceed with the development of the technology. So in the TRL 6, we are talking about prototypes or demonstrators of the technology. And then the other areas of the company will evolve the technology in order to have the products or service development and the operation to design and manufacture the products of the company. And another important model that we adopted at the technological development is the triple helix model for innovation. The triple helix model was developed in 1997 to explain the dynamics of university industry government relations. It states that the relationships between these three actors must be mutually beneficial for a successful innovation system. Each actor has its own role. Government provides funding, industry invests resources and expertise, and academia develops knowledge through research. Together, they form an interconnected web to create ideas, test them out in the real world, then refine them into products or services with commercial value. This allows for more efficient use of resources and encourages innovation to happen faster. So today we have projects based on this concept. So we have projects that will show later to you that we have involvement of the government and universities. And I will show to you how we can use this in practical projects that we are developing today. Now I'll talk about my area. The department that I work today is the Intelligent Systems department. So what is intelligent systems? To talk about intelligent systems, we can talk about Guadalupe. The Guadalupe was created, modeled by John Boyd, is a colonel of the U.S. Air Force that modeled the decision-making process in the military domain. The ODA loop is divided in 4 components. So we have the observe component that is where we collect information from environment using sensors. Then we go to the orient component, when we will process and analyze information provided the sensors to transform the information to knowledge. Then we go to the decide component, when we will generate course of actions hypothesis, and you generate an action plan. And finally, we go to the act component, when we will employ the means to execute the plans. And the cycle repeats a lot of times in order to have a best understanding of the environment and to create the best hypothesis and the course of action. So the intelligence systems area, we are committed to developing technologies to make it possible to have this cycle performed as better as possible. And as a final product of our development, we have the decision support systems, where we implement solutions for the decision-making process, providing good information for decision-making, and to have the best information provided for the decision-making people, in order to have the best actions and the best situation awareness acknowledgement for decision-making people. And you can see that our development is not restricted to aerial platforms. We work as well in the development of technology for the Navy and for the Army as well, in developing C2 systems for the decision makers. These are the areas that we are developing technology today. So here I bring you a general about the main disciplines employed in such systems of information systems. The first discipline is data fusion, when we process information from different sources to create a simpler and more robust situational awareness. Then we have the imaging intelligence, the use of computer vision technique to recognize patterns on videos, the distributed systems that we develop software and hardware technologies to create more robust systems. In case of destruction of parts, the remaining ones shall have consistent information for command and control. This is the importance to have a distributed system, not a central system. The communication discipline is important means to make information flow along participants and out chain of command, the reporters and the others. The modeling and simulation, since we are dealing with potentially dangerous environments, expensive assets, to simulate these elements is very useful for research and development. And finally, we have AI and data science, where AI complements data science and helps make machines intelligent. It allows machines to recognize patterns in data and solve complex issues. So these are the main areas that we are developing our solutions today. Okay, now I will show you some projects that we developed in the last years and some projects that we are developing right now. The first project that I'd like to comment to you is the distributed data fusion system for naval applications. It's a project we developed in cooperation with Brazilian Navy and Brazilian and Naval Research Institute, IPQM. In this project, we have some sites around the Guanabara Bay. In each site, we have some sensors installed, like radars, cameras, and AIS sensors. And the objective of this project was to increase Embraer readiness on data fusion algorithms using real sensor data in real environment. This system is capable of generating a unified vision of the Guanabara Bay, processing the different processing the information provided by different sources in order to have situational awareness, unified situational awareness. So we developed here algorithms for distributed data fusion, processing the data provided by different sensors installed in the different sites. We installed the sensors in different sites in the Guanabara Bay. Sites for belongs to the Navy, and we have besides the fixed sites, we have a truck with some sensors installed. This is the ground unit that can be transported to different places in the Guanabara Bay, and we have a boat as well with these sensors that can move around the Guanabara Bay in order to make the surveillance of a specific area. And in this project, we developed a communication link among the different sites, transferring information from one to another. And in each site, we have all the information available. So in each site, we have the data fusion processed locally in order to have the situational awareness of how the Guanabara Bay. As I said, this was a partnership with Brazilian Navy and counting with Brazilian government funding from FINEP. In order to say about the sensors, we have radars, we have cameras installed in each site, as well as AIS receivers. And we developed algorithms for correlation of the data provided by the different sensors in order to have a common situational awareness pictures. Better estimates for position, velocity, and coherent identification among the sites. This is a picture. In this picture, you can see this building that we built during the project. This is the Centro de Estudos located in IPQM. And in this building, we have a photography of. We have the possibility to receive data from all the sources, all the sites, and here we process this data provided by the different sites in order to achieve the common situational awareness, the common situation picture of the Guanabara Bay. So we have a link here, a radio link between this place and all the other sites around the Guanabara Bay. And in this place, we receive an information generated by the different sensors and process this information here in order to have this unified picture of the Guanabara Bay. We can see here the ground site that I commented before. In this truck, we have sensors installed, we have cameras, we have radars, and they'll have some antennas as well in order to make the communication among the other sites. At the right, we have the picture of the plot structure. Here we developed the plot structure. We process the data provided by the radars, and we can, after this processing, we can see the tracks, we can see the plots. That means detections of the ships that were detected by the radars in the Guanabara Bay. And here we can see the automatic target identification and the recognition system that we developed in the project, showing the ships that we found in the Guanabara Bay during the collection of the data. So we have this view from one site, but we can provide the same view to in the other sites as well. So in this form, we can cover out the Guanabara Bay area using the cameras and the sensors, the radars installed in the different sites of the Guanabara Bay. This is a picture from the screen of the C2 system, when we can see the tracks generated by the systems after the fusion. So we received a lot of information from different sources. In these systems, we integrated this information in order to have just one unified picture of the system of the Guanabara Bay. We can see the tracks represented by this yellow symbol. So each one represents a ship that is located in the Guanabara Bay in that moment. So it's a very challenging development here, because the process of the fusion, the development of the distributed data fusion is not so easy, because you have to have a unified comprehension of the situation in the Guanabara Bay. So this was very challenging to develop this distributed data fusion algorithms. And here we can see the final results of our work. We published a paper about this work in the Fusion Conference in 2020, showing the results of the summary results of this work. The other project we finalized last year. Now we are developing another project here in Rio de Janeiro, cooperation with TechGraph, PUC, and funded from Embraer. And in this project, our intention is to develop algorithms for automatic identification using cameras, and to develop algorithms for the tracking of the vessels and the ships in the Guanabara Bay using cameras and AIS data as well. So the main goals of this project is to develop a data curation methodology to build image databases for targeting recognition and identification applications, demonstrate the automatic target classification and identification in a real-world scenario, develop algorithms for target tracking using information provided by the cameras and the AIS systems, fusing information of these two sources. The status today, we are deploying sensor sites in the Guanabara Bay, in some places around the Guanabara Bay, and we are developing a containerized deployment architecture to run microservices responsible for several tasks for the detection, geolocation, classification, identification, multi-target tracking, data gathering, annotation, and depuration. So this is the project that we are developing right now here in Rio de Janeiro. The next project is the multi-sensor image-based navigation. This is a project that we are developing in cooperation with ITA, EAV, Saab, and the Linköping University. In this project, we are developing image processing and sensor fusion for aerial navigation in a GNSS-denied environment, using inertial data and image-based measurements to estimate the aircraft position, velocity, and orientation. We are evaluating the algorithms and the techniques using both simulated and the real data. So this is another project that you are developing right now. Another project that we are developing in cooperation with ITA, Saab, and here at the university is the cooperative threat engagement using drone swarms. In this project, we are investigating methods to development of managed and unmanned teams involved in autonomous drone swarm for cooperative aerial engagement. In particular, we are focusing on managed and unmanned teams of multi-rotor aerial vehicles, and the particular objectives of this project are to develop, simulate, and analyze high-fidelity dynamic modeling, flight formation control, guidance, and the collision avoidance, distribute the high-level decision-making, dynamic resources allocation, and evaluate the interaction between the high-level decision-making methods and the low-level control methods. In order to develop this project, we considered a defense scenario based on the loyal wing concept, when we have two teams, a managed and unmanned team, and the kamikaze swarm of drones that try to destroy the leading drone on a protected area on the ground. And then the mission of the loyal wingman is to defend both the protected area and the leader against incursions of kamikaze swarm. So here we are developing distributed decision-making algorithms in order to provide the best action and to select the best wing to make the actions in order to protect the leader or the protected area. This is another project that we are developing currently. Here I have a short video showing some results of this project. I will show to you. Sorry, I have this problem. Sorry for that. So I will start the video showing the results of this project. We developed this project first in a simulated environment, and in the next phase of the project, we will go to a real environment. We have real drones in the laboratory, making these same actions that we are seeing here in the simulation. This is the next phase that we start now, and we believe to have this scenario developed in an arena of drones in the next year. We have had a PhD student developing the algorithms for the load control, and another PhD students developing the algorithms for the distributed decision making in this phase. We can see that Weightless must to identify the threats and select the best one to attack and destroy the threats. And the decision-making algorithm shall select the best lawyer wingman to be employed in the defense activity. Each lawyer has two different guns, hypothetical guns, in order to use to defend the leader against the incursions of the kamikaze drones. Related to this work, had a paper published in the ICAS conference last year in Sweden, and we published a paper in the IEEE Access journal as well. So that's it. Thank you.
Hello, hello. Thank you, José, for your amazing talk. It's great to be able to bring you here for the second time, actually, but before José was just for meetings, and now he's presenting. It's great. So, questions from the audience to José about his work, or about things he has to do, because we have a lot of things in here in the university talking about autonomous drones, the Nautilus, about on the water, UAV, no, UAV is on water, but drones team actually right now have a idea founded and been working on those aspects. So it's very interesting talk, very important to us. So questions, things that you want to talk? Okay. 1, 2, 3. Ladies first.
Good morning. Thank you. I'd like to ask if the surveillance project, the surveillance from Guanabara project, is ongoing. It's being deployed. It's working.
Yes, thank you for the question. The infrastructure is available, belongs to the Navy today. So the Navy is responsible for the maintenance of the system, and the Navy researchers are using this infrastructure to develop the algorithms and to make another project based on this infrastructure, but is operational. Yes.
Oh, but because I want to ask about the incident where a recent incident where a ship drifted and collided with Ponte Niterói, and I would like to know if this project analyzed the event somehow.
Yes, the infrastructure can be used for this purpose, but to do this, we need to develop algorithms for intentions, or to analyze the trajectory of the ships. For instance, if the ship deviates from the route, the system shall provide an alert to the operator, and the operator must take some action in order to avoid the problem. So it can be used to do this. Yeah.
Thank you very much.
Thank you.
Okay. Thank you for the nice presentation. I'm Maia Claudia from Military Institute of Engineering. We are also very interested in what you are presenting. I was especially curious about the Guanabara Bay project also, because I understand that there are data coming from different sources with different representations. So my first question is this: if it's really heterogeneous data coming by, and how to gather them and fuse them in a way, if there is a data model behind it. I mean, to integrate the data and then fuse it in a single image. Thank you.
Okay, thank you for the question. Yes, in this project, we integrate different types of sensors. We had different types of radars. Each radar has a different protocol and different data formats provided by the radar. So we had to develop an adapter to translate from one format to another format in order to have a common format in the end. And we making this, it's possible to fuse the data. We need to put all the data in the same format in order to fuse the data. So we developed these adapters in order to make this transformation of the data, as well as the cameras. We had different protocols provided by the different cameras, so we had to make the adapters as well to have the same protocol on the format at the end in order to make the fusion. I know. Did I answer? Yeah. Yes. Yeah, this project didn't work with high-level fusion. We didn't develop a semantic algorithms to process the data. We concentrated on the low-level fusion, considering the signals provided by the sensors. But it's a good point that we needed to develop in the next project to take into account the semantics of the data as well. Yeah. Okay. Okay. Sure. Okay. Thank you.
Hi, good morning. I think this Guanabara, it's a project that is getting attention from a lot of people. We're also working on a project that do this ingestion of AES data, and also we have like integration with the visual information system for a couple of ports, harbors. My question is, you guys some kind of downsampling, local downsampling of the data, because like for IS data, we have multiple antennas and we have a lot of the same data for the same shift coming from a different place, sometimes with different time stamps, sometimes with like low quality the data from points. How if you can disclose like how do you aggregate the data into the downsampling?
Yeah, so we received a lot of data from the different ships at different moments as well. I'm not so specialized in the processing of this data, but I can say that we needed to filter the data in order to not use the poor data or data delayed in some time. But I'm not so good to answer about the process of the AIS data. One important thing in this project about the cameras and the AIS is that we have ships that don't provide the AIS. So in this case, we can use the cameras to track the ship. When we have the data, the AIS data provided the ship and the camera data, we can fuse these two information in order to have the track. So we are developing algorithms to fuse tracks provided by the cameras and the tracks provided by the AIS system as well. So specifically to talk about the methods to filter or to processing the AIS data, I can't talk to you so much now. Sorry.
Oh, thank you, Joseph, for your talk. Your time is running low, so thank you very much for your presentation. Thank you very much for coming here all the way. So thanks a lot. We'll go to the next question. There are some questions from YouTube that are provided to you for their analysis.
Okay.
If you want to know a little bit more about the data fusion field in the magazine that you have received, you see a lot of letters, 2-page letters, detailing some of the key areas of research. So high-level fusion that José has talked about, particle-level fusion, sensor-level of the data, high-level data. So you can take a look at the magazine and see the outcome prospects. Also, the magazine is available on PDF on the IZIF website, so you can also take. I took a lot of pictures for the next keynote from that. So thank you, José, once again. This research has been going on for around 7 years. I've been accompanying this project with José year to year. So amazing jobs, a lot of work, several sensors, big sensors, and a lot of data. Them. So it's congratulations on your work, José.
Thank you very much.
So, guys. So we are starting the next session. So paper 2. Paper session 2. The paper session 2 starts with a little bit different. It's from a paper that is online. It's the data imputation paper. Was originally from the paper session 1. We moved to place the keynote at the right time. So it's thank you for that. Let me take care about it. So while we are moving it, there are beverages here for you, like there is Guaraná, there is Pepsi, there is I think coffee may be cold. You can change coffee, guys. Change coffee, and there is some biscuits for you before lunch. Remember, lunchtime is 1 o'clock for you to avoid the lines. So we can start now. I guess the presenter will be Silvio Ribeiro. So one of the things I want to take a look outros before we go to the IEEE proceedings, we did the camera ready version, but there are still some papers with mistakes in names and affiliations. Please take a last look at your paper and at the format. And some of the authors that made the camera ready is still blind. Please, it's not blind anymore. You have been approved. So take a last look at the papers first to proceed to the final version of the papers. Silvio, are you ready to present? Make a sign with your finger. Are you okay? Are you ready? Silvio, are you ready to present?
Can you hear me?
Are you ready? We can hear.
Okay, can you hear me? Yeah.
Yeah. Go on.
Okay. Hello. My name is Silvio Ribeiro, and I'm going to present this work and data imputation techniques for network throughput measurements. And it was developed in the Computer Network and Security Laboratory at the State University of Ceará. The authors is Maria Clara Mesquita, me, Silvio Ribeiro, Ivo Pimenta, Francisco Conceição, Francisco Nobre, e the Professor Rafael Gomes. So this is the outline of the paper. First of all, I'm going to start for the context, followed by the problem and our proposed solution, the data we collected, the identification of measurement failures, the data imputation methods that we used, and the results, followed by the next steps. So the IP network monitoring services, known as MONIP, conducts end-to-end performance assessments across the IP network. This figure shows the IP network, and he has points of presence in every 27 states and capitals of Brazil, and he connected universities, education institutions, and governmental institutions. So to measure the performance of this network, use a persona toolkit that is a framework for monitoring services. And these measurements, is run is throughput, delay, threshold, and packet loss. And these measurements is temporary and periodic. So this data plays a crucial role in implementing new management solutions and conducting research and planning the maintenance of the network and expansion efforts. So in this network, measurements failures occurs, especially during the throughput monitoring, and it causes a great effort to the network. We don't know exactly the possible reasons for this, but we know that it causes gaps in the data and harms the data analysis process, especially during the research and development projects. That is what we do. And it causes a lack of information and the disruption of a time series about this throughput data. Okay, in this figure you can see in the rows every point of presence of the IP network in the columns, and the colors shows if the measurement, in this case throughput, is okay, is a high throughput between the links, and if don't, the orange and pink color shows that the network having problems in several points. So we propose a solution to solve this problem that we encounter, and we looked for identify measurement failures and correct this data by imputation. So we collect this data via Asmon API, that is an API associated to the persona toolkit that we can request data from the persona. And after this, we identify the measurement gaps in the time series we collected. So we perform the data imputation in these gaps to have a more structured time series to future data analysis. So we expect to identify the best imputation approach. In this approach we choose to use and provide better scenarios for the future data analysis, as I said before. In the data collection process, we collect data from January to June of this year. It's almost 150 days of data. And we select the communication points of Ceará and São Paulo, knows CESP, and Paraná, Amazonas, knows PR and AM, Minas Gerais, Rio Grande do Sul, and Paraná e Bahia, knows MGRS and PABA. So in this graphic, we can see the data we collected in the points for every theoretical every 4 hours a day, but sorry, every 6 hours a day for measurements per day. And but we have a lack of information per day, maybe one fault or two faults per day. So we chose these links because have different communication profiles, like distance, numbers of used links, and others. So first of all, we run an algorithm to identify these gaps in the time series, and we just we just search for a gap in every day by the information that we need to have for measurements per day. And we are organizing this. In blue, we have the collected successful data. In red, we have the failure that we encounter. So to solve the problem, we use the imputation methods, and the first of we use is the linear interpolation, that we can vary the points that we can that we consider in the interpolation. If I have the interpolation between x3, for example, and x4, we use x3, x4 to know the point between them, or x1, x2, we can choose in the window can vary, and we choose a value between 1 and 3. So this method assumes that data has a linear relationship. So the second method is the moving average and moving medians, that we calculate the moving average and moving median for every time series, and we fulfill the time series by this moving average calculation. And we have just like the linear interpolation, we have a completeness, a more complete time series that we can analyze. So it's very different in those sides for moving average and the median calculations to enhance the robustness of our imputation method. So the next method is the KNN. There's a machine learning method that consider a weighted neighborhooding between the data around the gap that we can fulfill. And various window size, we can test it. The value of k we can vary by, and they perform similarity. So for the results, we use the root mean square error and the accuracy by definition of measurements range. We define intervals of the measurements, in this case throughput, and we assume that is a positive value if if the data in the interpolation, the imputation is the same range, and is not if the another range. So for the RMSA, we can see that the KNN performs better for the MGRS datasets, and in another ways, another data, we have you have the ruling median in the PR AM datasets that perform better. So for the accuracy, we have a more equal scenario, and the KNN performs better in the again the PR AM datasets. So for the next steps, we look to explore additional imputation techniques, AI based beyond the KNN, and another statistical methods like spline, and propose a new imputation approach for network monitoring context. We can do prediction with the inputted data, is the objective of imputation. Do a better quality of data to forecasting and so on. We analyze the hyperparameter by grid search and in conjunction with other imputation techniques that we can research. So, and we also can do analyze another communication points. Thank you. That is.
Hello. Thank you. And for next paper, okay. Okay. So the next paper, ESS technologies evaluated by a swarm revolutionary meteoric scene. Information system concepts application in smart grids.
Good afternoon. I am Leonardo Veiga, and at the moment I am undergraduate student in computer science here at UFRG on Computing Institute. The presentation is about energy storage system technology evaluated by a farm evolutionary risk in a microgrid system. This presentation has 4 parts: the introduction, background, experimental design, performance, and conclusions. This work presents an application of an evolutionary meteoritic DeepSU in an optimization problem to get the best configuration of hybrid microgrid system. Okay, the AGMGS is a low voltage energy generation, distribution, and storage system. Here are illustration and a real image of a hybrid microgrid system, grid connected. We are considering 6 main components: solar panels, wind turbines, battery energy storage system, controller system, load demanding houses, and the public grid. So CDIPSO is a population-based algorithm that was recombination, mutation, and selection operation. Okay, this algorithm starts with a random initial population and applies these operations to get new solutions. It's inspired by two others evolutionary meta heuristics, the differential evolution and the evolutionary particle swarm optimization. Here are the CDIPSO equations. Okay, the equation of motion has 3 parcels: the inertia, the first parcel, that represents the permanence of movement, and the second parcel is the simulation that applies search strategy, and the third or last parcel is the communication, and that is the exchange of information between particles. The other 2 equations are disturbance in the weights and the best current solution. We are in the optimization problem. We are considering 3 objectives. Okay, the cost of electricity, loss of load probability, and renewable factor. We want to minimize the first 2 objectives and to maximize the third objective. Okay, we are using this fitness function that was created from the weighted sum of the objectives. Okay. Here is a table considering 4 information about batteries. We are using storage price, number of cycles, efficiency, and lifetime of each battery. We are using the temperature, solar radiation, white speed, and residential load of the simulated region. We are the region is a city in Spain. Okay, the name is Cadiz. Here is the experimental design performance. We simulated the microgrid with 2 models. Okay, the first model considers photovoltaic generation and the number of turbines as optimization variables, and the second model adds the S capacity to the set of optimization variables. The simulation considers a set of 10 particles evolving from 10 generations in 30 independent executions. We are using 100% for mutation and communication rates. Here are 2 tables. Okay, the first table is relation. The first table is about the first model, and the second table is about the second model. Okay, the batteries with high costs in the first model had a decrease in this cost in the second model. For example, this battery is a high cost in the second model. We got some less cost. Okay. We selected 3 batteries to focus. They are gold, two of lithium and 1 of redox, because they have good characteristics, and they have good results. Okay. Here are charts of the energy supply. Um, this chart indicates that we got a decrease in the second model. Okay. The green part is the renewable source, and we want to maximize it. The orange part is the public grid supply, and we want to minimize it. And the blue part is the surplus. Okay. We got less surplus in the dynamic model or the second model. It's good because the energy is less is not going to the trash. So these charts are about the microgrid performance for the 3 batteries. In a typical spring week, we can see that they had similar performance. So the batteries obtained similar results. Finally, the conclusion. This work proposed an electrical dispatch controller system for AGMGS based on a swarm evolutionary algorithm, the CDIPSO. As a novelty, it was proposed to include battery capacity as an optimization variable in the second model. Both models obtained similar results, but the capacity optimization model or the second model obtained less surplus. It's good. Moreover, these batteries stood out as the most advanced technology because they are good characteristics and they had good results in the simulations. That is. Thank you for the opportunity.
Thank you, Leonardo. Paper very well received, very well evaluated. For next paper, we have an online presentation, wizard-based federated learning for regression tasks. The presenter will be Caio Cortada, so feel free whenever you want to. So, Caio, room is yours.
Yeah, I'm here. So, good afternoon. My name is Caio Cortada. I'm from São Paulo State University in Sorocaba. I'm a student of Leopoldo that presented earlier, and I'm going to talk about. You talk about user-based federated learning for regression tests. In the presentation, I'll talk about prediction with embedded algorithms. Afterwards, I'm going to talk about the challenges that we face when trying to implement those algorithms. A little bit about this predictive learning, and then I'm going to talk about the regression analysis with wizard neural networks. Not deeply, but I'm going to introduce it a little bit. Talk about a little bit about the training model, and our proposal for the convergence model. Since it's a positional paper, we don't have results, but we have a proposal of how to implement it afterwards. And how does it all come together? So firstly, I'll talk about the importance of prediction with embedded algorithms. I separated this into 2 big groups: reliability and privacy. For efficiency, I have we have the resource efficiency, because we talk about embedded systems, embedded algorithms. So it's already a really resource constrained environment. So to make it work, the embedded systems can use a lot of resources. They use a lot of processing to serve the server like computer. So have also have real-time decision making, because when we talk about embedded algorithms, embedded systems, embedded sensors, little devices that they gather the data and already develop the processing and the prediction to real-time decision. And for reliability and privacy, I would say system reliability is about the sensor itself, because if we know the data that we are working with, we don't need to enter the data. We don't need to process the data in other places. Know the data that we're working with, so we have reliability on this. And also we have an security and privacy, because all the data that is together in the sensors is processed between the sensors and devices, so it's not sent anywhere to any other means. So private data or sensitive data is not something. Now everything is good and so, but what are the main challenges? For one part, it's good because we use less resources. It's also bad because we have less resources to work with. So limited resources is one bad thing for us. We need to work around, and then we can achieve our goal. Another thing is data variability. We need to really work on our pre-processing of the data, so our RAM or our sensors can work with the data, so they can receive many kinds of data and still work around and get a prediction. And also testing and validation. We need to make sure that all the sensors are really calibrated, and also the models are all the same for all the sensors and devices, so we can achieve a good result on our tests and our neural network. And also, now I'm going to just sum a little bit on federated learning. Federated learning just as a type of training or learning, that we have a central server that converges all the models trained in a lot of clients, that they have the same model distributed. And then this trained model in all the devices and clients, are sent back to the central server. Then the models are converged and then sent again to the clients. So we have a decentralized training with privacy preserving collaboration, because the data that is being used to train the models, the models locally, are not sent to the central server. And also is efficient because we have many models being trained at the same time, and they converge, and together they become a bigger model and robust model. So, and with this, I'm going to enter in my wizard neural network analysis, regression analysis, and we have like 4 main topics: efficiency and processing, because wizard neural networks are lightweight. They are weightless actually, and they work on the RAM, so it's a really fast processing. They have real-time regression tests, just as I said before, and they have the adaptability to diverse data sources, because when you work with wizard neural networks, we do the pre-processing of the data that the neural network receives, and it can adapt to many kinds of data. And also, it has compatibility with distributed learning because it's really lightweight, so we can implement them in sensors and devices around many clients. So with this, I'll get into a little bit on the training. We gather the data, we do some pre-processing on the data, we binarize the data in a big binary word, and then the binary word is allocated to many memory locations. And in these memory locations, for our case, it is regression tasks or regression wizard. We have 2 spaces of memory, one for the counts and one for the partial average, the value that we enter in the binary gets. And then we create this kind of structure here. And then after the pattern learning and memory allocation, we can do our pattern retrieval and then prediction, just with some linear regression or other types of regression. And that's for the training. I'm not going to get too deep into it. And the thing that is the main topic here is how to mix wizard with federated learning. So how are we going to converge our wizard neural networks in a global model? And we had two ideas before. The first one was to sum up the counts. This is just a regular wizard, but a regression wizard. It was just to sum up the counts, and actually like to make sense. Because when we sum up the counts of the wizard, we had the counts to make sense. They sum up the number of times that the memory was accessed to make sense in the model. And also thought to make the average of the counts, but it didn't sum up as we wanted to, because when it worked with integers, the number of integers when we divide by different with an odd number, it wouldn't be the same as we sum up all the So we got to this later model, this possible versions for model for regression wizards,
So we have now two spaces of memory, one for the count and the other for the partial average. And we maintained the sum up for the count memory sum up space. So we're summing up the counts for each wizard with of the memories, and then we're doing the average of the partial average. So we have this structure here later. The converged model is doing the sum up of the counts, and doing the partial average is an average of all the partial average. So we have a pattern that converges all the other wizards that we have on our federated learning model. Oh, sorry, I'm a bit nervous, so I'm speaking kind of fast. And this is for our brainstorm of the convergence model for regression wizard. And now we're like, okay, how does it all come together? How we're gonna mix federated learning with our types of wizard, and what do we want to do with it? And we thought some scenarios, but I separated two of those scenarios. The one is prevention of heart diseases, or just diseases in general, because we can use, I thought heart diseases because we can use wearables and sensors like pacemakers to measure heartbeats and then prevent maybe a heart attack, and to predict if someone is going to have a disease related to heartbeat missteps and stuff and something like this. And also regarding to health issues, I think it's really important that we take in consideration privacy preserving things. So when we talk about privacy, I think health is a really good point to look for, to develop a project on it. But the thing that we focused more was weather forecasting, because we already have a lot of data on the internet about weather forecasting, and especially in Brazil right now, I think it's a really good topic to hang on, because these heat waves, they're not common, and we should know how to prevent this. We should know how to predict the weather. So if we could create a reliable model spread around the world and many sensors, and spread around Brazil and many sensor or devices, we could develop a really strong neural network that could predict climate situation, climate scenarios that we could not predict normally. And I think, I don't know if I did too fast, but I think that's it for my positional paper presentation. And thanks for watching.
Well, now we go for the last paper of the session. We have a no-show, I guess. Juliana, can you confirm that? Make a sign. No-show. Like the third paper, EU network entity towards 3D depth estimation, was a no-show, so it will not be presented. So we go to the last paper of the session, using satellite and weather station data to build a nowcasting model for precipitation presented by Vieira. Thank you, Eduardo. I'll just ask, there are some people that present the next paper session. Please try to introduce your presentation at the beginning or during the launch before the next keynote, okay? Thank you.
Okay, good afternoon. My name is Eduardo. I'm professor in CEFET, the Center for Technological Application, and this is joint work with LNCC and PESC UFAJ. This is actually work from two students of ours, Ramon and Augusto. They weren't able to be here, and I'm going to present our work.
As an outline, I prepared the introduction to provide you some motivation for our work. I will proceed by presenting the data sources we used in this work. Next, I will present the methods for the solution. Next, I will present some results and some discussions about them, and I'll conclude with some final remarks. So, precipitation outcasts. Well, this term is defined as the short-term forecasting for rainfall events. So there's all kinds of levels of forecasting, like where you may be interested in predicting what is going to be in terms of rainfall the next week or the next month. But in this context, we are interested in outcasting, which is we are interested in what's going to be in terms of rainfall in the next hours, 2, 3, 6 hours at most. That's the nowcasting scenario. And this problem is essential for addressing some numerous socioeconomic and environmental challenges. This problem has traditionally, in the past decades, been solved by using numerical prediction models, perform some data simulation techniques using radar data, for example. But these methods suffer from some problems, particularly based on spatial coverage, lack of spatial coverage. And that's our motivation for this work of ours. So the research idea in this paper is the following. We wanted to fuse data from satellites, the weather satellite come from up in the sky, and weather stations, ground-based weather stations. And concretely, we aim to create an outcasting model using some machine learning algorithm. Doesn't matter which machine learning, it could be anyone. In our paper, we use XGBoost, but it could be any other. And we wanted to create an outcasting model for the geographical point where a specific weather station is located. So our research hypothesis is presented in this page. So we wanted to test if using these two sources of features would, by fusing these two sources of features, we would be able to build better models in terms of predictive performance. That's our research hypothesis. So that's it for the introduction. I will now present you the two data sources that we use in our solution. So there is this weather satellite which is called GO16. 16 because it was launched in 2016, some years ago. Here's a schematic picture of the satellite. It's a very powerful device. In this next page, I don't expect you to read it, but just for you to have a high-level idea of the huge amount of information that you can gather from this satellite. Each one of these bullets is a so-called product that we can access, programmatically access, and it's gathered by the GO16. And in this paper, we investigated the use of this particular product, which is called total precipitable water. What is it? Let's see. So maybe a meteorologist would spend hours talking about this concept. I'm not a meteorologist, I'm a computer scientist. So for our purposes, TPW is defined as the depth of water. So think, for example, of a bucket of 1 square meter here, and think of all the atmospheric air above it. And in this column, there is water vapor. What would happen if all this water vapor would condensate in this bucket? So this height is the measure of the TPW. Okay, that's the main idea. That's in essence the concept of total precipitable water. And this is one of the dozens of products that Go16 provides us. So for this particular product, this product is available every 10 minutes of the full disk. Go16 is a geostationary satellite. It is fixed above the Americas. Well, it was meant to measure, to observe in North America, but as a positive side effect, it measures Central America and South America too, which is good for us. And it is and this product has a very high spatial resolution of 2 kilometers, which is also good. The second data source that we used was some weather stations come from the MET system. So in this map here, you can see Brazil's map, and each one of these dots is a weather station, is a ground-based weather station. Here is a picture of one of them, and each one of these weather stations measures several variables on an hourly basis. And for our purpose, from the perspective of a data scientist, what is relevant is that we have a multivariate time series coming from each one of these dots. So what was our methods? Let's talk about it. So our data processing pipeline is the usual one, nothing special here. So we have our data sources, which come from the Go16, the TPW product in MET weather stations. We did some data ingestion, some exploratory data analysis, some data processing, and after the data was ready to be used, we used XGBoost to train on our nowcasting model. There are several details here. I won't have time to describe all of them. And in the next pages, what I'm going to do is to provide some relevant details about some steps in this pipeline. So for the weather station data, you remember that map from Brazil, several dots, dozens of dots. We only experimented with 5 of them, which are presented here. Each one of these rows is a weather station. The date which it started to operate in the geographical position in which it is located. All of them are located here in the Rio de Janeiro municipality. Please keep in your mind this acronym here, WSOY. I'm going to use it in the next pages, weather station of interest, which is the weather station for which I want to build the nowcasting model. As for the TPW data, we downloaded each full disk scan of the TPW product from the December 19, the date in which this product started to provide data, to September this year. We next processed each one of these full disk scans to get the TPW values for each one of the latitude and longitude of our 5 weather stations of interest. So as a result, we have a univariate time series for each one of these weather stations of interest with values every 10 minutes of TPW. So our first challenge here was to conciliate these 2 sources of information. On one side, I have a 5-dimensional time series coming from the weather station of interest with temporal resolution of 1 hour. And in the other side, I have one univariate time series with 10 minutes, providing data every 10 minutes. And so what we did, we took the TPW time series, 1-dimensional, every 10 minutes. We did some aggregation. We took the mean, and we transformed this time series in time series with 60 minutes temporal resolution, only to conciliate with the time series coming from the weather station of interest. So that's our resulting time series. With this resulting time series, we applied this well-known slide window to put the data in the tabular format. We'll skip that. We applied several kinds of transformation techniques, but because, as you can suspect, we are working with real-world data, several issues here. I'll be glad to talk about them in the Q&A. I'll skip for the moment. We then framed the problem as a binary classification problem, either rain or no rain. And for comparison purposes, we fitted two models for each weather station of interest. The first model, we fitted the model using only features coming from the weather station, and in the second model, we used features from the weather station plus the TPW value. Well, for the results, a common behavior that we got is that none of the model was good at predicting the rare occurrence, which is rain. I didn't get put the data here, but 99.7% of all the events is no rain. It's a highly unbalanced data set. So there is this problem. But for the total of 5 weather stations of interest, our approach was able to produce better results in 2 of them, and in the other 3 of them, we got a tie. Here's one of the tables. There are several other tables in the paper. I will skip for the moment, but the interesting result is highlighted in yellow here. For the no rain class, both models took the same F1, but for our model using the TP-table product, we got a slight improving the F1 score. As final remarks, our preliminary results were promising, but not very convincing. We need to continue this work. Actually, the big challenge here is the extreme event. As you should remember, we binarized the problem, either rain or no rain. But there are actually 5 levels of rain. No rain, moderate, weak, strong, and etc. So for future work, we intend to frame the problem as a multi-class classification in order to consider several levels of rain. We also intend to perform experiments in a greater subset of weather stations. Remember that Brazil's map with several dots. We only experimented with 5 of them. We also intend to perform comparison with some numerical weather prediction models and do some ablation to understand the outputs of the model and also incorporate other satellite products. Please remember that page in which there were dozens of products. We all used one of them. Yeah, I think I'm done. Thank you. I'm happy to answer questions in the Q&A.
Thank you, Eduardo. Juliana, if you can open to Caio, if there is here for answering questions. So we have 4 papers in this session, Caio and Cesar actually. So if Caio and Cesar to be placed on the screen for answering, Eduardo and Leonardo, if they want to answer a question. Are there questions for any of the 4 papers? Yes, please.
Okay, I'm Luis Ferreira from the University of França. I'm visiting him at the moment. It's Eduardo. It's for you, Eduardo. Thanks a lot for your presentation. I was wondering if you take data from different sources and then you have to align this. This looks to be the biggest challenge, that you are sure that you have the measurements being aligned, so that you are really combining things at the same moment. Can you explain why this isn't the problem or solve this problem? Because these are 2 different sensors, data, and then at different moments. So this looks to me like a problem.
Oh, can you hear me? Yeah, I'm relying on the sensors, right? Because each one of them, both of them, have time stamps. TPW data have timestamps every 10 minutes, and the weather stations have timestamps every 1 hour. I'm starting from the point in which I rely on these timestamps, but there could be some uncertainty on these measurements. I didn't consider that.
As long as I remember from what I learned a long time ago, because I'm not really from this area, when you have two different time sources, that generate timestamps, you are never completely sure that they are really aligned. Yeah,
Yeah.
this is a classic problem.
Yeah, we didn't consider that. Thank you.
More questions? Someone? Okay. Any of the papers?
Yeah, but it's again for Eduardo. Sorry to pick on you. I'm just curious. How do you define rain? So, for example, if in 10 minutes didn't rain, then it's no rain, or I mean, does the rain has to happen when the measurement is taken, or throughout the 10 minutes?
Yeah, thank you. It's the accumulated rainfall within the hour. So each weather station from IMET gives us 5 numbers every 1 hour. And for the precipitation value, that value was the accumulated value within the past hour.
Okay, thank you.
You're welcome.
Guys, we have can you see if there are questions on YouTube? So have quite a time for more plus 1 or 2 more questions to any of the authors. No questions. So no question from anyone, no question from YouTube. Okay, great. So guys, it's about an hour, so it's time for lunch. Just some small announcements before. We have the lunch goes from 1 o'clock to 2 o'clock. Then we have the keynotes. After the keynote, we have paper sessions 3, 4, and 5. So if you are from any of those sessions and you haven't placed your presentation here in the computer, you can place it. Otherwise, it's okay. For those that are not from the Federal University, you can launch. There are 2 measurements, kilowatts, they just from the corridor up to block H, or you have projectors at block F. There are 2 good projectors as air conditioning. What is an advantage? If you want to, there are also trailers beside. On those trailers, you can have like meals too. They are usually cheaper. And if you want like snacks, there are also hamburgers and everything else if you want to. And feel free, there are several options nearby. And I'm going where there is air conditioning, so it's just say. So I think you can take your things here. I think there's no problem. I'll be here shortly after. So if you want to place your PDFs now, I'll be here too. And I'll be on hold until 2 o'clock. See you guys. Thank you for your attendance now, and hope you're enjoying. Other thing, if some of the authors or people that didn't get the kit, just let me know. Okay? Você ganhou aqui, João.
Boa tarde. Vamos recuperar. Não, calma que não começou. Não começou. Pode falar então. Tá bom. Eu assustei agora. Bom, então nós vamos começar, né? A primeira palestra vai ser do próprio Cláudio sobre como que extend my paper to 2024. Então, basicamente, como eu tinha comentado aqui no início, né, um dos principais objetivos desse seminário é criar uma comunidade, né, que faça com que tanto no Brasil quanto na América Latina sejam mais representados nas conferências de Information Fusion. Tá? Então, para isso, nós temos um dos objetivos é que muitos dos papers que estão sendo hoje apresentados possam ser entendidos e submetidos para a Fusion 2024, que vai ser em Veneza, na Itália, e também para a Fusion 25, que vai ser aqui no Rio de Janeiro. Tá? Então, essa palestra que o Claudio vai estar fazendo agora é um passo a passo, né, de como fazer isso aí, de como pegar um paper que está no nível de workshop e garantir que ele esteja numa situação onde ele vai ser aceito na conferência Filho. Tá? Pergunta, eu estou falando em português, mas não... Alô? Quando dá ok quando começar a transmissão, que a gente muda a língua, faz o switch. Tá, agora só quando é só você dizer que a gente dá partida. Ok, we are on. Dá partida aqui no inglês. Now, sounds strong. Okay, so declassar. So welcome everyone. Those online, I already was talking with those here. So the goal of this specific presentation by Professor Miceli is to provide you with a step-by-step way, a flow, to enhance your paper so it gets a greater chance of acceptance in Fusion 2024 and Fusion 2025, which really aligns with the goal of this whole workshop, which is to create a community of interest here in Brazil and Latin America. So with that, I don't need to introduce Professor Claudia, and please enjoy and try to extract the most from this presentation. Thank you.
Thank you, guys. Wow, this is a very interesting thing. At the first time that we talked about this workshop, it was not a workshop. It was meant to be a winter school, or summer school, or hot school. Anything that happens in Rio stays in Rio. I don't know. So it's because we wanted to not only tell people what this information fusion is, because it's the first question that I get. Claudia, what's your specialty? Data fusion. What the hell is that? So it's is this machine learning? Sometimes. Is this particle filtering? Often. It's about uncertainty, usually. So the first thing that I always get is what is it? So this is one of the things we're trying to solve right now. So the second thing is in Brazil at least, does it have polish? So yeah, it does. It's a good one, actually, pretty good. So, and the third thing, what do I do? Because I have no idea what data fusion is. I have no idea what can I show, what can I do, and I think this workshop shows a lot of what data fusion means. So, but now you have this workshop to represent those papers. What can I do to extend my paper to Fusion 2024? We have this strategy for publication. So if you take a look at the format at Fusion 2024, the paper goes from 5 pages to 8 pages. Our workshop goes from 4 pages to 6 pages is on purpose, because now you can get this paper, extend 30%, and then publish on Fusion 2024. And more than that, the same reviewers that are in this workshop are the reviewers that will be on the conference. So the main idea is how I build something that is reliable enough and you don't get frustrated. Because I think one of the things that is more frustrating about a workshop, and when you get a workshop from a group and you publish in the workshop and then you go to the conference, you get destroyed. It's because this does not belong here. And this is not what we wanted at first. So what I'm trying to summarize here is I've been in Fusion for the last 10 years, and I've been reviewing Fusion for the last 8 years. I have several papers published in the conference. I've been in the group for several years right now, and I've been doing research for a long time too. So what I'm trying to summarize in this conference, what are the most common mistakes in this year workshop, and what do you expect from Fusion? So it's a guideline for you to go to the next step. So La Fusion is here. You are enjoying it. I hope so. At least there's coffee. So the air conditioning is great. So, and now what? So we know what now is Fusion. So Fusion is a very traditional conference. We are IEEE based. So we are not from IEEE. There is this discussion in the group, but we are IEEE based. We share a lot with IEEE AESS. We share a lot of researchers, a lot of research. If you see into the magazine that we gave you, we about IEEE MFI. So a lot of those, and for my students, you see those conferences are the ones that I would like you to go. Just saying, imagine. But this is our objective. So we are, even the workshop dates is meant for you to be prepared, because if you know that the deadline is on July, you know that the deadline for the conference is around March, February to March. So you have from November to February to extend your paper. How about there is vacation? Come on, there's still December, there is February itself, there are 3 months for you to extend your paper. But if there are the same people reviewing, what do I need to do to get in that? What those guys are expecting? Who is the people in the conference? Because this is something important. Are they from computer science? Are they from engineering background? Are they mechanical engineers? Yeah, there are a lot of people like this in the conference. So it's a no-brainer. You are here right now. It's a good conference. There are possibilities for special issues. There is it's the IEEE format that you already know how to do it. You don't have to think. It's easy. You can go there. If you are approved, it's a good sign that you are doing data fusion of some sort. But how do I prepare now? Okay, I have the paper I was accepted for 4 pages, 5 pages, 6 pages, 3 pages, position paper. What do I do? If you are in a position paper, you have a lot more, you have some more work to do. We have like short papers on fusion. They are not usual. We don't have many, but you always have some short paper session. We are discussing some interesting things right now. We are going to that we are going to propose that stay up to the closing. There are new stuff, some news that we would like to share with you. But if I'm in a paper like 4 to 6 pages, what do I do? How do I get accuracy? And the idea is simple. Let's see what people had more problems with. So let us make a guide for you to be prepared for this presentation and to see what the community wants to see. So what are the challenges that we have during the review process itself? Like yesterday, me and Paulo, we stayed the whole day after Paulo's speech. If you haven't seen Paulo's speech, it's on past YouTube channel, so you should take a look in there. After his speech, we spent the whole afternoon working on the conference, taking a look at the reviews and seeing what are the major problems that the papers had and what were the major complaints that the reviewers had. A lot of the reviews were very dense, very important, and I hope you that are here have got good reviews that were helpful in some ways. And if you didn't like your reviews because of depth or because they are problems or because you believe people didn't understand the paper, let us know. The only way that we can improve the reviewing process if you have some feedback on that. But the major problems that we saw from the people that are from the conference are this. What are those that I'm going to show now? The first thing, format. man. Come on. We have Paulo. Pode ver. Take a look. So, format. The first thing that you have to take care about the formats, and it was really, really difficult, and you have to be truly kind, is about the formats. People in the Fusion conference are kind of strict with that. So, I took. If you take a look at the Fusion web page and you compare to the Fusion conference web page, I copied and pasted exactly the same type of evaluation. So it's a blind conference. So you should not bring any indication of the authors. And several papers had that. It happened to a point that in a given moment I said to Paulo and the reviewers, just give them a strong reward to let them pass this time, because we are trying to teach. So, of course, there are a lot of this, but do not forget about the form. In the Fusion conference, they will cut you. So, but not only this, you see, like, a lot of people follow the IEEE conference format. The IEEE conference format is already on overlift. You can, like, just choose it and go from the template. There is a lot of these templates on LaTeX on the IEEE website. You use the conference templates. It's pretty easy. If you use Office, but then, like, if you can't avoid it, you can. There is a Word template on the IEEE website. And not only that, take consideration about equations, numbering, the way you use template tables, the way we use figures. Try to bring the figures close to your to the text. Sometimes a lot in the comments of the reviewers, or the figures are 2-3 pages away of the text. So for the review to take a look, and this is something that I always tell the students, every reviewer is probably reviewing like midnight, which is the last thing that we do in a day. You're dying, and you are making a lot of effort to review your paper, make it easy for us. So if the format's the first thing that you see, and the format is like totally out of scope, we will cut it. So take a deep look at the format. A lot of the reviewers contacted us about that. So please take a look at that. Here we are in this role of trying to form a community, but in the main conference we have a lot of papers. It's a giant conference. Sometimes I receive like 6 or 7 papers at a time. Paulo, I think it's the same, 5, 6, 7 papers. Especially us that are on the TPC itself, we receive a lot, because some of them they expect us to send super reviewers, but most of the time we do all the same. And if you take a paper out of format, this is something that is truly bothersome. And of course, keep to the page limit. This is something like position papers with 3 pages, or full papers with like 3 pages too. So if there are a bottom line and an upper line, try to keep it up. Of course, we can understand like position paper pages that will be cut in the final version. It's something, but it's still bothersome. So if you have more material to present your paper, great, Fusion's there, don't worry. But cut it to the format, because otherwise, if you accept the paper without the format with more or less things, sometimes it's a bad thing for the Fusion conference, but you can fall into the copy area, that we don't know what is actually your productions, the novelty of your paper. So if you have some doubt about the format, enter contact with the organization. We will do our best to help you. There are a lot of people who are willing to help, willing to answer your questions about this. But this was one of the major problems that we faced at the first moment, and almost lost it around 5 or 6 papers. It doesn't seem much, but if you take into consideration that we had like 40 something papers, if you were one of the reviewers, and you see on EasyChat 36 papers because you have to put it beforehand. A lot of papers because you're too far away from the format. And this was something that I didn't enjoy. It's not enjoyable. You have to do. So take out sometimes the conference are much more strict. Grammar, sincerely, but you can't if you can't read it, you can't review. And it's not only grammar but syntax. Sometimes things that you would pass for a grammar check. Any grammar check, like word grammar check, or even Firefox grammar check, would solve those issues. Please take a long time on that. If you see a paper with a lot of typos, we understand that if you do have those issues, and we submit everything on the night of the same day, so sometimes we try to leave it open to the next morning, and I forget about it. One forgets about it. But like I'm going to sleep, and tomorrow take a look because I want to spread it anyway. So we try the best to keep it open, but then take a look at the format, the grammar. The grammar is that people complain a lot during the conference, during the review process. Not only because I understand that it's not like the construction is weird. Some of the comments about the construction is not a problem, but sometimes like words like simple words like nowadays, things that are easy grammar check to do this. And there is a lot of tools that can be used to enhance protection, like Grammarly, like even ChatGPT. There are some issues with ChatGPT for construction of text. We took this one of the things that we have complaints about, but I'll talk about it in a moment. But take for instance 2 or 3 hours to review your paper. There are some papers that were clearly copy and pasted from other papers that were not in the same spot that they should be. So this is one of the things that we have to take a look at. And about ChatGPT, there is nowadays, like we had a recommendation. If you use ChatGPT to build text, it's not forbidden, but should be explicitly said what was the components that have been used on ChatGPT. At the same time, the same thing that we have now, the similarity checks on the papers that we receive automatically. Now there are tools to verify if there is the content that was producing use LLMs. So we have to take this into consideration. So if we could use these LLMs tools to try to enhance your text, but please review this. Just don't cut and paste stuff without rereading again. And sometimes those elements include mistakes from your document that doesn't make sense. So the text, the format, is the first thing that we see when you see your paper. If you can't understand your idea, you can't understand what is going to be done. And those, for me, were the most, a lot of the papers that didn't pass. And we tried to, you see, we are doing like very short presentations. Why are you doing such short presentations? Because I wanted as much papers as possible in a single day. We even thought to extend for 2 days the conference, but I think I will die. It will not be nice for the university, because, but we try to put almost, we have a lot of papers that we are in what are called weak exception of accept condition. They were receive a borderline and a weak accept that we have to cut. So if you are in this condition, you're not out of the game. You can take those clues to try to enhance it. But a lot of papers that were cut, one of the reasons were because of that we couldn't understand the idea properly, or we had like one of the contradictory reviews. So that someone accepted the paper and someone gave a reject. And most of the there was a very interesting case, a paper that like both the guys said that the paper was to be accepted, the guy who said the paper was to be rejected, had a very similar review, because you had me and Paulo took yesterday, not only yesterday, but in the day that we sent you the results, we looked at every reviewer's group to see if there's a lot of contradiction. If the review is not contradictory, but the results are, we were okay with that. This particular paper have a weak reject and a weak accept, and they are saying the same thing. The paper is good, but I can't understand why it's in an information freedom conference. So this is one of the points that's most interesting. A lot of people are just publishing. Am I on the video because I'm starting walking? And Juliana said, you are able to see me? No, you are able to see me because I'm starting walking. Okay, never mind. So, never mind. So it's this paper was quite interesting because both the guy that accepted and the guy that didn't accept had the same thing. We can't understand why it is information fusion. And the guy that said, I believe it is, but it's not said. And the guy who had reject said, I believe it is, but it's not said, so I reject. So you see, it's a matter of clarity and why it's included in information fusion. And that's one of the reasons that we brought the magazine to you today, because you can try to map your paper, your solution, onto the categories that we have about information fusion. So this is one of the things about scope. Some of the papers we didn't see in the scope of the conference. This is something that we had to. So please take this grammar, take this format things into consideration specifically. Literature reviews. That was something that was really, really annoying for some of the reviewers, because some papers that were not in the position paper scenario lacked a lot of comparisons. Some of the papers that were accepted lacked comparisons and did not even explicitly said this on future works that we like comparisons. Because if the author knows that there's lacks of comparisons of their approaches with approaches that are too similar in literature, this is a problem. So there needs to be a little more depth on the literature. Not necessarily. This is something that should be clear to everyone. There is no need for your reference to be from previous fusion conference. There's no need for that. It was never a question in the review process to be, but at least we have to have fusion papers in the topic as references. So what is the comparison you're doing to prove that your approach is correct, better, or that reduce uncertainty at some level? How do we compare to the other guys on literature? So this is one of the things. A lot of the students' papers had those problems. You see clearly that people that lack this review, not only the review, the comparison, the critical thinking about the literature itself. This is one of the major problems. And a lot of, especially the senior reviewers, guys that are in the Fusion Conference 4 years, and they are very respected in the community, were saying people need to have a broader the view of literature. And Claudia, I didn't have space to place it, but now you have to have this level of commitment to the previous reviews. There are a lot. If you don't know references to look at about information fusion, you can provide. Just send us a link. Just send us a link. We will be more than glad to help you on this. And this is something that we had a lot of problems. Especially for me, my students, what I'm truly annoying with this, I think every book starts a literary review. I don't give a damn about the proposal. Don't give a damn about the introduction. Don't give a damn about programming before you understand where you are at. Maybe your product is already sold. And this is not a bad thing, no? We are here to do innovation. This is a topic of the past week of Fusion. It's innovation, to do new stuff, not to repeat worse versions of things that already are. So that's one of the things that we have a lot of conflicts about. experiments, especially how do you experiment? Where do you get your data from? What is your source? One of the things the IEEE gives us as a directions as reviewers is, where is your source code? A lot of people that you are getting, like people, we did an implementation. Where? And how? I have no indication whatsoever of how those things were implemented. Anyway, we don't have like a GitHub repo. We don't have sometimes even a Colab link. We didn't have like a Google Drive or any indication of the source code used for the reviews trying to reproduce our experience to see if they are legal. Of course, most of the time we don't have time to actually put into the source code. But if someone wants to see it, it must be possible. It has to be possible in some way. So it's not a matter of actually if this experiment were correct or not. But most of the time, the matter is what you have done is reproducible in some way. And this is one of the things that were a lot of complaints about in the reviewers. So these are one of the key aspects that you have to be aware of. So if you're doing this paper, understand that the Fusion Conference, the conference for I would like to say it's an engineering-based conference. We like to see stuff getting done. So you see, the conference is a very interesting conference in the sense that it's not only people from the academia, universities in general, research labs, but also from companies. You see a lot of people from Toyota, Audi, from I can't speak Schlumberger. I can't speak the name of the company. Bosch, a lot of times. Duhan. Do you remember? Yes. Metron. A lot of those great companies doing. If you see, like in this magazine that you have received, there's a very interesting paper from that was keynote last year. That the guy have used data fusion to find a lost city on Peru. It was very cool, and this shows that we are doing research with companies that are doing stuff, and so we are very based on the things that you actually have done. There's a lot of theory in there, and there are a lot of sessions with very intricate math, with very intricate physics, but there must be results. We are often about the results. Yes, Ecuador. Going for gold, finding lost gold cities in Ecuador. It is a paper. It's a paper that didn't come from the academia, it came from an enterprise that was hired to discover and using PCA. It was awesome. Very, very interesting. And I discovered that was done. Probably still am. Because why the heck haven't I thought about something like this? Because it's awesome. It's great. So we need stuff getting done. And so we need like details about your experience. We need details about how have you implemented. We need details about the data that you have collected. We need details about the data sets. We need details about like the challenges of how to implement it. This is one of the things that most of the best. I have this thing like the best paper at the Fusion Conference is always extremely distributed. Like to get like we receive around 300 to 400 submissions a year, I guess. Sometimes more, sometimes less. Between 300 and 700 is a big between. So always the best papers are around like 10 to 15 papers. And there is a committee to choose those papers. And usually those papers have something that very interesting about their experience. They point the shortcomings of their experience. Where do we fail? Why do we fail? Why our results are not perfect? Why are not our results, where can we improve? In the experiment, they discuss not only the theory aspects of your paper, but also the shortcomings of how they have implemented. We know that sometimes we try to do simulation, or our machines are not what we wanted them to be, or didn't have the resources, or we didn't have time to complete all the simulations that we wanted. And then we submitted it anyway because the idea is good. And then we will extend it later, like in here. But please give us this indication. This is on one of the things that are more, if you go to a reviewer, there are more company-based or more business-based, they will ask you about this. So these are the things about the structure of the paper that are very concerning to us. But now, okay, we passed, I have reviewed my paper, I've seen the structure, I've seen the results, I pointed out the things I'm going to do, like my introduction now points out exactly what I'm going to do to show how can I extend my result. Well, ask us. IZ gave us this task to help you be prepared for Fusion next year. We received the reviews from the reviewers. Take a deep look, not only to fix the issues for the camera ready, please, now you can put the names in the camera ready. You see a lot of the camera ready that are still blind. Now there's no need to be blind anymore. You can just produce the final paper. So if you take a look at La Fusion Easy Chair, there's still open for us to change for the last because there's still some papers that are blind. So use the reviews from the reviewers, use us, ask us to help you with this endeavor. We are trying to do very hard this, and we are at a very starting point. We're not meant to be the owners of truthing whatsoever. We are just a starting point for you to reach other people. And we are more than glad to put you in contact with other people inside of the Fusion community. I cannot stress this enough. Take a look at the reviews. Some of the reviews were really depth. And I said I was talking about Paulo, that one of the reviewers that have been accompanying his work through the years. You see, when I entered the Fusion conference for the first time, I had just recently finished my PhD. And I was in the conference to see the guys that I had excited doing my PhD. I was like starstruck. Oh my God, this guy! And now I drink beer with some of those guys, and it's fun. And we have karaoke, it's great. After beers and karaoke doesn't. Yeah, there's some great, but not in video. So it's one of the guys that is one of the great researchers, a very cool guy. Do these reviews that I think they are the most impressive reviews that I have ever seen. He usually writes as much as the paper itself in the review, so it's really broad. So some of you receive just great reviews. Use it. Those reviews are what you are expecting in the paper. And some of the reviews brought not only questionings about the paper, but brought our suggestions of improvements. Take a look at those suggestions stronger. If you receive, take a look at the reviewer's confidence on your submission. Some of you saw reviewers confidence 5 or 4. Usually those came from people from the community. Take a look at these reviews strongly, because that's what we want. We already like your paper. We're here, we're accepted. It's not like you are with problems. But even if your paper is not accepted, but received average results, you can improve this. Future works. Go for it. If everything is okay, you've fixed everything the reviewer has said. Your paper is great. It's like a Shakespearean paper, and it still doesn't have 6 pages. What do I do? Start about the future works that you have said. Work on them. Because if you didn't complain about your future works, it's a great point for you to start something new. It's a great point for you to extend everything that you have done this year. It's a great point for you to go to. But not your future works. You have access to all of the conference papers. Take them, and they are. If you take a look at for instance, at the workshop this year and the Fusion conference that are on the IZ website, the proceedings are there, you will see a lot of future works that could be implemented. And if you see those papers on the Fusion conference, you have access to the data sets, you have access to the code on the conference, and then you can use this to improve your own paper. So we are so open that you have access. You don't have to pay for anything to have access to the conference papers. You can get it right now. You can get, if you receive a Google Drive link for those who have registered, with the authors, especially with the final kind of version of papers in the workshop. So use not only your future works, but the future works of the other accepted papers as a stepping stone to producing your stuff. And take a look in the previous Fusion conference. Take a look at which were the sessions, which were the tutorials that were given. These are good starting point for you to extend your paper. So the question that you should ask yourself are, what is the uncertainty on my data that I can produce? How can I produce better decisions? What are the fusion models that I'm using right now that can be used to improve my decision issues? Take a look, or you can go, even if you want to be more simplistic, go to the magazine and try to map. There will be in each of the topics that your magazine is showing you, there are references. Most of those references came from people from the community. So it's great. So another thing is, ask us. Those guys, we are here to help you. Ask a mentor in the community. If you go to the magazine and go to the website, there's mails for all of us. Those are actually guys on the conference, okay? They are actually pretty great. So we are here to help you. So ask us, send us email. We are providing now ways for you to contact us, to be here with us. We are open. There are several groups inside of the conference from several countries. Sometimes just to give you a collaboration. A lot of people from Germany, a lot of people from France, a lot of people from South Africa, a lot of people from nowadays China. There's a lot of people from China. A lot of people from the US. So East Coast and West Coast. And now we want to form groups here in South America. If you're watching this, ask us. We are more than open to receive people and to form groups. There are groups that go to one conference and never go. It's okay. It's fine. But there are groups that go to a conference and go to the second, go to the third, and start being there. We want to know and to help you. If you want to be there every year and there are ways for us to do it, ask one of us. Claudia, but I don't want to you or any of the conference to be co-author. It's fine. We still love you. Don't worry about it. So ask us, send us what is the idea? What do you think? Like, we receive a lot of those comments from people on the website asking us what do we think if the paper topic is within the range of the conference, and we try to do this as much as possible. If you're working like in machine learning, there is one of the sections of the previous conference that were about machine learning papers, about optimization papers inside of the conference. There were papers from finance, there were papers from Industry 5.0, me and Mercadion. We received a lot of papers from machinery. We founded a special section about industry. Actually, it was Industry 4 at the beginning, but we are moving on. So there are a lot of papers on these special sections that will accept your paper. Maybe you are in a topic that can be used to this. We can found a special session to you. And this is one of the things I think it's interesting that we are going to propose. I cannot be sure, but this is one of the announcements. We are trying to do next year a special session about the fusion. We are proposing a special session, the fusion conference and not fusion. So like a special session of papers that came from the La Fusion conference to go to the main conference. So this is one of the opportunities to keep this work going, like, or maybe to be a workshop. So there is this very, even if you are not convinced, we have this very interesting thing. In the first day of the Fusion conference, there's the Data Fusion School. There is a series of lectures 8-hour time that I have attended this year because we are launching the data fusion course, the UFLJ, for next year. I have attended I've attended this, and there are a lot of students that attended this year and helped see the whole scenario from information fusion. And the guys who give those lectures are the guys who have been chairs in the previous years, are some of the most influential guys in the conference. And especially one of my favorite talks is for Professor Bartolom. That Bartolom is a very influential researcher in the fusion community. Even the prize is given in his name. He's alive. There's a great speak about a prize. Should be a prize given in your name. So ask us. People are nice. There are a lot of people wanting to help. There are a lot of people wanting connections. There are a lot of people that are not in academia and naturally so wants this connection. So talk to us that we are trying to do this. So don't worry. We're friendly. We don't kill anyone yet. There's always a first time. We have karaoke. So like, if you think that we are going to complain to us, no. After 3 beers, we're singing every language. Don't worry about that. So like, we're not here to criticize your paper, but to aid you to form, because like, if there's no difference from like a paper from ICML and a paper from Fusion, it's a weird thing. So we can help you to shape into the format of the conference. And if you are here, come on, you already like your book. No? If you didn't like your book, we wouldn't accept it. You see, for the point we received, if you took it into a normal base, this workshop would have like an acceptance rate of around 30%. Because if you have like a normal time of presentation, we reduced for having more people, but the workshop was quite disputed, and we didn't accept any paper that had an average of less than 1. So at least 2 we accepted. And that was one of the discussions 3 weeks ago that we were having. If you want to have like 12 papers, and then 12 papers is actually less than 30%, like 25% is a pretty strict conference, but we would cut a lot of papers. So that's not what we're trying to do. So you're already interested in what you do. You are already interested in how to solve your issues, already interested in the solution that you have, and in keep in touch. So we found also this La Fusion Telegram community. What will be provided in this community? The links for the next conference, the links for the next opportunities, the links for the data, to put you in contact with researchers. We try to put as much people from the community here as possible. And we want to not only give you opportunities about research, but about jobs too. There are a lot of people who go into the Fusion community that goes saying that goes like, please, we need people, and we don't have people. So a lot of the companies go into the conference just to hire people, and they're always. So if this is an opportunity to group that. Embraer was always looking for good people. Yes, Metron is always looking for good people. All of those companies, and there are some jokes about it. Like some companies go to the Fusion conference every week, and they put like a bench just to please hire. Please just why don't you give me a call? It's interesting. So we are trying to be as open about it as possible. We are not just for academia, but you have to have a job. You have to have a paper. You have to have research about it. So we are friendly. We're here to help. We're here to give you those directions. So start now. The deadline is not too close, but it's not that far either. So the idea is to maintain the workshop on November, and next year try to place the workshop together with some of the SBC conferences together. We want to create a relation with the SBC. For those that at home that don't know what SBC means, it's Brazilian Computing Society. This year we didn't have time to, but that's something that we want that to do. 5 minutes. Wow, I speak too much. Yeah. So, and the objective is this: I want to have as many of you in the conference in 2025. It's going to be here. It's going to be great, hopefully, and it's going to be close to us. So it's an opportunity for us to create a community that can help themselves. It's the first time not only in South America but in Latin America. And you see the map that Paulo placed in the beginning of the workshop today. You see the southern hemisphere. There's like 2 in Asia, 1 in Australia, 1 in South Africa. So in none here. So little experience of these big conferences in here. And even in Rio, we receive a lot of good conferences, but not just water issues, like for instance in the northern hemisphere. So we can be this thing, we can be this point of starting up to have a conference in Rio, and sometimes a conference in Buenos Aires, or in Lima, or in Bogota, or Arequipa, for those, for some of the colleagues that have been in the TPC. And the first 2 Lab Fusions we are trying to do here in Rio, but the next one, Lab Fusion 2025, Lab Fusion 2026, if there's still interest of the community, we can try to do this, and other countries will be a very interesting thing. And I hope you start, and maybe we stop having just one Lab Fusion, and we can do like a berry fusion or something like this, if you have still interest in that. But we need you to come to us and take your questions. This is the target, this is the objective of this. So this was it. It was, from my perspective, it was brief. I hope I didn't bore you very much, and I'm open to questions, disillusions, and everything else. Thank you. Go on. There's something on YouTube you can ask because I'm walked out something. Talk. Sorry? The deadline, I think, is February 28th. Yes. So usually we extend for 2 weeks, but I can't count on that because usually Venice, people want to go to Venice. Please.
Very expensive to come, and especially for Brazilians and Latin Americans. So I was wondering if Fusion 2024, if they have any, let's say, program or special programs, special prices, because with this CAPES pressure to publish things, and also without the scholarships and the money to send you to the conference, it's different. It's difficult to Brazilians to attend.
This is something that we're pledging right now. There you have some good news at the end of the conference today. Some of the things that we have already done, but if not for 2024, we are aiming to do the Fusion 2025 to be the cheapest ever. This is something one of the things that we're trying to do, to be at least half of usually is paid for the conferences. So the idea is to find a way to pay for the costs. So because like things like we all want like good goodies at the beginning of the conference and the great good hotels, and but these things are very expensive. So we are trying to take this conscious decisions about the things that we can do to reduce the cost and bring as much people as possible. And one of the things that we tried to do in Lab Fusion was a hybrid format, to have people that were not from Rio. We received some questioning about it, because even for Latin American people, Rio is a quite expensive city. Even for people from Rio is a quite expensive city. So it's, but if you compare to Europe or the US, it's not that expensive at all. But we are trying to achieve people in scholarships and to get a special sponsors. So like instead of the sponsors pay for the conference, try to get sponsors to pay for scholarships if possible. Of course, not everything because we have a lot of costs, but try to get as much sponsors as possible, especially for students. Because I know everyone there's academia know we are getting it. And I'm not that old, okay? It's in the video, I'm not that old. I'm half age, very fit, not so much. But we have to new people coming up. So you have to have new guys in the conference, new people discussing those problems. So we are trying to, at least for student papers, have some kind of support. Where in 2025 we can ensure that we are doing this. 2024 we're discussing, but we have already a lot of good results. People from other staff gave us green light or something. They're very cool to talk. So stick to the closing of the conference. Something more? Something else? I'm on time already. Great. It's fast. Okay. So thank you very much once again. Thank you very much for attending here. Thank you very much for listening to me, and thank you very much attending online. So move to the next session for the third paper session. Thank you very much. And for the third paper session of this workshop, not that old, not that young, but now I need to get this. For the next paper session, we have the first paper is from heterogeneous integration for vessel activity monitoring in territorial waters from Matheus Emery, Carlos Eduardo Barbosa, Madalena Lopes, Gabriel Martins, Oliveira Costa, e Júlio Moreira de Souza. Is the author here or the author is online? Juliana, the author is online? So, bring it on.
Magalhães. I'm presenting the paper titled Heterogeneous Data Integration.
Just one moment.
For
Change the screen, please.
Me?
Just one. No. Here. People is not seeing your presentation. Just for 1 second. Okay. Thank you, Matheus. You can go, please.
Okay. I'm presenting the paper titled Heterogeneous Data Integration for Vessel Activity Monitoring in Territorial Waters. I will comment about following topics: introduction, challenges and proposed solutions, CVMA framework, evaluation, CVMA framework, and conclusion. Introduction. Maritime domain awareness, especially following the September 11 attacks, become crucial for addressing sea safety and security. MDA involves understanding elements in a specific maritime region, focus on vessel and assets. Improve MDA is vital for monitoring maritime traffic and supporting operations for security, economics, activities, and protection. Every day, maritime authorities face challenges, including knowledge gaps, dependence on solutions that are not trustworthy, and the proliferation of data-driven approach. While culture proposes tailored solution, literature highlights the need for privacy preservation of the dataset foster accessibility and reuse. Especially, each culture has building his own owner solutions because the scenario are different. The maritime scenario are different. The research faces challenges mainly in detecting vessel in territorial waters. The research are focused on detecting vessel in territorial waters because the vessel types in some maritime domains particularities are unique based on location. Brazil being a continental country, so it presents various distinct scenarios. The images below represent two different scenarios of the Brazil. In the left image, there is a vessel in a certain location, but we cannot identify or recognize it with the available sensor data. On the other side, in the right image, we can see the pool data from sensor about the vessel location. Based by sensor data, the vessel should be there, but is not. How you can see them in the right image. So, challenges and the proposed solutions. In the present scenario, the first challenge is integrating source from different characteristics, such as onboarding tracking system and camera images from the shore. The second challenges are concerning protecting the data privacy on search sources. It's important because it's hard to find a data set in the internet because the privacy is a good challenge. So in our proposed solution, we developing the CVA MDA framework to overcome these challenges. The framework uses computer vision to integrate camera images with ship logs and SEC4ML to anonymize the automated data set for the vessel detection model. So, this is a picture of the CVMD framework. The framework is composed by 4 layers. The first layer is a data acquisition layer. The second one is a data integration layer. After that, the anonymization layer and the detection and classification layer. In this picture, we can see simple examples of the data acquisition layer, the capturing the vessel images, and the working with different data sources from the GPS of the GPS vessels, like Cistron, IES, CMAP. So we have to integrate them. The integration, we can understand, some people can call this with fusion or integration or combining. Data integration, we combine vessel image with vessel registry and the movement data to build a specialized data set to support MDA Brazilian scenario with particular vessels. Because Brazil has particular vessels, China has own particular vessel, the United States also. After we build the anonymization layer, so we apply the SEC4ML approach to anonymization ID, type, country, and introduction noise to special coordinate attributes. Two, because we want support other researchers. And the vessel detection and classification. Each layer, we use different streams. In the first is employ the vessel detection. In the second is responsible for refining the detection capability for specific vessels. For it, we use the transfer learner by fine-tuning. So we evaluation our framework. We executed the automated annotation with some images. An image can have multiple vessels and the anonymous vessels types as ship 1, ship 2. For example, oil ship is a ship 1. Tankers a ship 2. Okay, so we train a classifier with different epochs. So the analysis of the results demonstrates that the use of the proposed solution can enhance classifier quality in multiple types of vessel of specialized MDA area MDI Brazil is a huge area. For conclusion, this short presentation, this work aims to demonstrate the capability of using a fine-tuning based solution for vessel detection. So, we focus on use a vessel detection framework, concentrating exclusively on tailoring each for our specific context. In the image below, we just figured out an example of vessel detection by fine-tuning in the left side and a simple vessel detection in the right side. Look, in the left side, you can see the fine-tuning. The types of the ship are specialized. In the right side, no, just boat is a general. Well, thank you. Thank you, Professor Miceli. Thank you, everyone.
Cool. Thank you. Thank you, Matteo. Now for the second paper is wind-to-wind fault classifications using scattered methodological data fusing from Daniele Pina, Fernando Sá, Kelly Velosa, Rafael Coutinho, Angel Vieira, Rodrigo Toso, Rafael Guerra, and Diego Brandão. I think it's an online presentation too. So get on. Please, Daniele, welcome, and it's yours.
Okay, thank you. Hello, everyone. My name is Daniele Pina, and I will present our work wind turbine fault classification using SCADA and meteorological data fusion. This is the flow that we follow in this presentation. So, wind energy is an important resource of clean and renewable energy available in nature, and that has been expanding over the last few years all over the world. However, like any mechanical system, wind turbines are susceptible to faults that can impact their efficiency and energy output. Detecting and classifying these faults is critical for reliable turbine operation. The problems related to wind turbine maintenance are usually electrical system component failures, and those arising from extreme weather conditions. Some component failures do not occur so frequently, but a single disturbance can cause hours of lost productivity or even shutdown of the turbine. For this reason, the most effective way to reduce maintenance costs is to monitor the status of critical components and predict their malfunction before the system fails. Early fault diagnosis is a critical factor in significantly reducing maintenance costs, and modern wind turbines have a data collection and monitoring system known as supervisory control and data acquisition, SCADA. As the name suggests, this monitoring system is powered by multiple sensors that provide measurement of critical process variables. However, extracting answers that enable failure prevention for a large amount of data is not a simple task and requires sophisticated methods. Our objective is to explore the fusion of data from diverse sensors, including temperature and operational data, to comprehensively assess the condition of wind turbines. Real datasets contain a larger number of attributes. However, not all of them are informative. This means that the number of variables available exceeds the number needed to understand the phenomenon that we can be studying. Picture extraction is an example of dimensionality reduction applies an algebraic transformation to the space of the input dataset, resulting in low-dimensional subspace. In the literature, most works are based on operational and event datasets, such as SCADA. Some papers use simulated data from the SCADA system, which can be a risk as the data may not generalize well to real data and perform worse than expected in production. Many studies related to fault prediction in wind turbines use machine learning techniques as a solution. Some authors emphasize the data scarcity and the need for diverse datasets from different turbines. In this context, data fusion, a process that brings together information from different sources, is increasingly used to improve the classification of faults in wind turbines. The proposed pipeline consists of 4 main steps: data acquisition, data pre-processing, dimensional reduction, and training algorithms with model evaluation. We use a free dataset provided by Energias de Portugal. The availability of this data was based on a challenge proposed by the company in which the objective was to detect failures in wind turbines. The records were extracted from the SCADA system from 5 wind turbines measured in the years 2016 and 2017. In total, we had 5 datasets were available: match datasets of meteorological match variables, failure datasets of records of failures occurrence of each wind turbine's components, logs the historical of normal and abnormal events, signals the SCADA system sensor variables from the most important components and production values of each turbine, and locations of turbine containing latitude and longitude. This graph shows the temporal analysis by meteorological variable, and it can be seen that of 40 variables in the meteorological data, many had 0 variation over time, and there is an interruption measurement to February to April in 2017. And this next graph shows the 15 most relevant cross correlations. Some variables are high correlated. In data pre-processing, we inputted some instance of time. There was no measurement. We created the label based on the difference between the failure time and the measurement time using the concept proposed by the company. Variables with little variance and named offset were removed from the dataset, and numerical data normalization was applied to eliminate the discrepancy of units. In dimensional reduction, we applied a PCA, principal component analysis, to eliminate high correlation and reduce the dimensionality of multivariate data with minimal loss of information. This table shows the first 10 components generated by PCA with their respective percentage of explained and accumulated variance. The first 6 components have an end value more significant than 1 and explain approximately 85% of the data variance. In other words, we're losing around 15% of the variance. Interpreted this component, we have the first principal component can be called by the wind indicator component. The second principal component can be called the ambient temperature component. The third is the humidity component. The fourth is the precipitation. And the fifth is the wind direction. And the sixth can be the ambient temperature and humidity variables together. Machine learning algorithms are sophisticated and autonomous computational tools that can construct model data and solve complex problems. A one-class classifier aims to capture characteristics of training instances to be able to distinguish between them the potential outliers that appears. The main difference with supervised algorithms is that training dataset only has examples of the normal class when modeling the one-class algorithm. These figures represent a supported vector machine example. The algorithm seeks to find the maximum margin hyperplane that best separates the points of different classes. To measure the performance of classification algorithms and verify the model's ability to generalize truancy data, several methods can be used in this context, such as confusion metrics, accuracy, precision, recall, and F1 score. We training the model using 80% for training and 20% for testing. The experiments were performed using computational routines implemented in Python. This table shows the performance metrics of the one-class SVM model on the test basis without optimizing the parameters, and it's possible to observe a high F1 score result from the gearbox when turbine components if you compare the literature. So wind turbines are complex systems and require maintenance. As the number of sensors within these systems increases along with the data they generate, The challenge lies in effectively aggregating this data. This aggregation is essential for enabling machine learning algorithms to harness the health of information and construct more robust models. For future works, we test other algorithms such as ensemble methods and neural networks, also evaluate oversampling methods and other dimensional reduction techniques that consider the time dependence of the data, and evaluate the performance of new experiments comparing current results and evaluation statistical significance. That is, thank you.
Thank you, Daniel. You will join in a QA session later. Thank you very much. So we have a change of order in the session. We'll try to present the fourth paper from Jesus Echegaray. It's about learning.
Thank you.
The
Thank
name
you.
of the paper is Digital Education Platform with Directing Curricular Content for Public Schools in Rural Areas of Peru. So we changed the order. I will be the last presenter of the session because we're already tired of it. So it's give you a break. And there is hot coffee, the beverages here if you want to. So thank you, Jesus. It's a pleasure to have you here. Thank you very much and welcome. It's yours.
Okay. First of all, good afternoon for all the present. My name is Daniel Chegaray. I study in the University of the Peru University of Applied Science. I work in this project with my partner Renzo Arroyo. I try to describe all this problematic, what I develop, what I design with my partner, the field tests, and the final results and recommendations. Okay, let's start. First, in agenda, it's a problem, the objective, the related work, the design and implementation, the conclusion, recommendations, and finally the biographical references. Let's continue. Well, the problem, okay, so first of all, it's identified with the no existence of interactive curricular content limited to an educational platform in public schools in rural areas of Peru. But this problematic is about other origins like the inexperience or the origins. It was the inexperience use the digital tools, that sense of digital content, the insufficient or interactive content tools in my country, the inexplored education content, the deficiencies in government investment. eh, they are tried, but it's not the best, and the network instability. So in the rural zones, like the internet is very poor. It's very poor. Okay, continue about that. The objective about my partner and me and the project is the design and develop an education platform that provides interactive curricular content for these students. Uh, and also if they have good internet or don't have any or poor internet. Let's specify the objectives. The first objective is define the requirements, doing the benchmarking, investigate about the problem so much, investigate about other platforms, education platforms, and others. Next is the design, the logical and physical architectures. Next is all investigate and design it is for the implementation about or app, desktop app, and next is carry out the file test. While is in the rural zone of and the next. Okay, let's talk about the relay works. In this case, we investigate about papers, journal papers about digital education, interactive course in education, uh, open repository resource using to universities or schools or college and others. We represent like all Malishiva, Olaisi Badatunde, Filipin Portela, Matias de Cuipere, Nura Mahan, and Philippe and the others. Continue. Okay, let's talking about the design and implementation. The logic it's simple. It's the components, the how works the all the platform. It's the I have the app in my computer. Uh, uh, and one time I received the information about my peer, my relay peer in the cloud. What happens if I don't have a connection? Okay. Also, the design is to connect with other computers by peer-to-peer connections to pass the course if they have to me, and the others, other turn. But I didn't understand me. Let's continue. The physical architecture. It's about the application system, the cloud deployment, the connections about relay peer. The network is if you have or don't have is it's important here because if have a lot of internet, you can connect to the cloud service. But if you don't have, you can extract the data little to little. Okay. Okay, let's talking about the technologies to implement. We use technologies like React, Node.js, GAN.js. What is important because with this technology, we can connect the computers like relay peers and peer-to-peer. Next, use Express to backend, GitHub to the repository, Railway app where we deploy the relay peer in the cloud. Electron is more specific to develop the desktop app about the project. We interact with user interfaces, use virtual DOM with React, with server-side JavaScript. It's decentralized this project. Minimalist. We cross desktop applications. We continue. Well, I will show you about the views about the presentation. In this case, the panel view will control the main console, the way with dashboard and resume. And the login view. In this app, we name it a mouth app. What is a wise man, a sabio in Spanish? Well, education. In Peru, a mouth app is the relation about education. Okay, continue. The state is the material education material view, which the teacher can see all the grades about the students, the primary, secondary, the initial of school. Next, we have the perspective about the student when he see the course or the material, educative material. In this case, is it's maths. It's fractions. I see. He can see, he can learn about this online education. Next, we have see the view about the editor or administrator teacher view. We can create, edit, delete, adjust one things about the education material. Next, we can show the about all the school. You can see like admin or like a teacher, all the students and all the teachers are in your school. And this is the practice support application with questions and answers about that. Also a contact section you can call by email by me or my partner. Okay, let's talk about the field test plan. This is a work plan. It's an analysis process. The plan is create a course for the teachers in their schools and provide teach how to use the application and get a feedback about them. Continue. The evaluations is the course synchronization about rural zone and urban zone and rural zone and rural zone, and the users feedback. Okay, the schools the field tests I improved is the School of San Jose, de Jesús de Recalango. As a pilot test for now. The more tests in the future. Here is a manual user to provide in physical to teachers to learn about the course. And the results, the uploading of course, I stay in Lima and my partner is stay in Malacalango, which is a rural zone level 3. The relay pair functionality works really fine and very good. The course view, the course access is very poor internet in Mala. Results, all the objectives finally give you a very good concept about this project. I really hope the synchronization is very good. It's very good about the distributed databases, the manner will get information. Also, get the functionalities the teachers like it and not like it, and get that information for future works about this project. Also, I really get the information about set up this platform like a standard in my country. I really like to the rural zones get the access to digital education. And my recommendations was expand the coverage, improve accessibility, teachers training, evaluation and feedback about the platform, collaboration and synergies with other papers, with other students or other workers, and finally, a monitoring evaluation if the impact of this platform and this type of district data works in the rural zones in my country. Well, it's my biography references about the conference paper. Thank you so much for take your time of work. Is interest for you. I have the opportunity of other time.
Thank you, Daniel. Great paper. It's very interesting to see you on the QA. I'll try to be as fast as possible. The last paper, I'll be the presenter. Let me close this here. And it is. So, the last paper is this maritime situational awareness and multi-sensor knowledge-driven pipeline from Gustavo Gusta. That is here. There. Gabriel Martins, that's my PhD student. He's not here today. Diego London, that's David from the University Navy, and me, Claudia Farias. So, the idea is that the international commerce relies on connecting routes. So we use, although there's a lot of planes, a lot of cars, things travel by boat. And that's the truth of it. So managing search and rescue areas, assess activity within the exclusive economic zone, and monitor threats to ensure safety and security are primordial tasks that we have to do. So how can we use the visualization analysis is extremely important, as you see in Mateus' work at the beginning of the session. So the maritime domain awareness of decision support systems that are capable of dealing with multiple sources, data fusion, and real-time support, data fusion, and customization, data fusion, and context-based approaches. So what we're trying to do is to use techniques to do this maritime traffic visualization, focusing on manual decoupling of collision routes, so we can lose boats not only because of pirates. It's interesting that there's still pirates nowadays, crazy stuff. But we can have like disasters happening on the trajectory. Our constant trajectory for heat maps. If taken recently in Rio, we had like this boat that almost collided with the unitary bridge. So things is still. I had to filter myself right now. So a lot of anticipation encoding, so a lot of retreat data about where the boats are is very important and special. So we have a lot of interpolation of geographic data, and we have several algorithms that could be used for that, but they are not fast enough to be done in real time. And the question is, although you can try to predict stuff, right, you can plan, you still need techniques to solve these in real time. So with lack of real-time capabilities, customization, and contextual data representation, which is a problem. Not only for commercial boats, but also for the Navy, for conflicts, for rescue people. So this is an issue. So we try to use a knowledge fusion approach. Knowledge fusion is a technique developed in 2014 for by the researcher Shimona Dong from Google. At the moment, she was in Google. Nowadays, I think she's in Meta. Everyone's in Meta nowadays, so it's complicated. The idea of knowledge fusion is to try to gather data from a lot of different bases and try to sort this data in a common base. So we have not only the sources and the data themselves, but extractors to try to reach a common ground. So what we're trying to do right now is get this geospatial data and data about the vessels themselves to try to develop a pipeline. So I would extractor a way to get the raw data, to transform this into a given external format that could be read for any application, and to perform data quality and data assessment techniques to eliminate duplicate missing values and try to transform this in something that can actually be used to storage it. So this is actually an ETL pipeline, and through this create beacons that may map where the vessels are. Then to make this map able to visualize the vessel trajectory. So this is, and also use GeoJSON to distribute the data. So not only we are predicting and creating a map able to see on real time where the vessels are, but we're trying to distribute for anyone that will try to use it for good purposes to use that. But of course, people use this for everything. So the case that we have done this is a position paper, is still on ongoing work. So the case that we have been developing this right now, it's on the Santos Basin, a huge oil exploration area of Brazil. So the knowledge that we have is to cover 350,000 square kilometers with 2 exploration areas with 25 exploration sites. We have evaluating traffic in the surroundings. So our hypothesis, the ship naturally avoids these areas due to light. And hypothesis is not moving. So this is the map, the heat map of the transmission of the vessels. So the heavy maritime traffic we see in 2022 is this one up here, where we have offshore activity and operational support. So we are trying to extract oil, sell platforms, and the boats are going there. 5 minutes, okay, it's perfect. So we are trying to avoid do the natural avoidance due to the light using figure 2. So we're trying to remove this data, the noise data from here to see if it is true. So the offshore navigation channels, where we have evidence of problem natural avoidance, so we are trying to see if the boats will stick to those routes, the routes on the one, instead of the 2. So the one is actually what it is actually is, and the 2, it's the data that we collect. What we want to try is if the data that we can actually collect has no mistakes. So the one in the middle has higher risk. So the middle, I mean, if I put a boat in here, there's more probability of collision. That's what you're trying to avoid. If there is a higher probability of collision, can I use a broader perspective, a different route to try to avoid those collisions? And the concern is that there is this spoofing problem, that the data is so polluted that when you try to map it to an actual visualization, this is the actual route. So you see those lines covering the map. This is the spoofing problem. So in this so noisy, this is a considerable limitation for knowledge-driven systems. It's also a way for falsifying data, because if you can try to map your burglary or traffic into noise, what's the difference? What is anomaly and what is malicious data? So it's used to hide a passage to identify a location. You can just say that my not my GPS, but my transponder, my actual curator of data. Calma, cara, relaxa. Vai dar tempo. So it's easy to have to hide the advances through identity. So it's a threat to maritime command. It's a way to evade maritime surveillance. What we're trying to do is like you get at the black box of an airplane and try to modify it on hand. So it's a way to conduct illegal activities, but also it's a way to show something like this happens. It's a way to show that someone is doing. It's like, for instance, if you take it to Brazil, if you go to a Tor link, the federal policy considers you like a suspect. This is a way to consider someone as suspect. But not only this is a problem due to illegal activities, but since I don't know where your boat is coming, this is raises the risk of accidents. So what we're trying to do right now is to use this data, use this to create filters and create alerts to the boats, and try to, given that I have a high level of noisy data, to try to create alternative routes. So the system will provide decision making for various sectors, such as oil exploration, energy exploration, environmental impact assessment. You will enable to identify frequently used routes, risky traffic channels, seasonal variations, but also be able to help the Navy and policy into identify malicious entities. And through enhanced spoofing detection. So the conclusion, we are proposing a multi-sensor driven pipeline to enhance this situational awareness, to support various sectors, and we will try to focus on anomaly detection right now and integration. This is part of the PhD work of Gabriel Martins, probably from the master's from Gustavo Buscar. So we are trying to do this and develop advanced visualization techniques for these different sectors. That's it. Thank you. I'm on time. So with this, we have the third section of the day. We start the fourth one. I think most of this section is an online section. I'm not sure. I think the first paper of this section, I can't remember, is Biospecific Methods in Fusion Approach for Pattern Classification by Categorical and Mixed Data, from Gabriel dos Leites, Jimenez, Santos Salvador Santos, Elizabeth Varner, Carolina Marcelino, and Carlos Duarte Pedreira. It's online. We hope it's okay. So, huh? No, okay. Well, it's here. Vai. We are running out of time. This issue was actually because we did the QA. She's asking if we can present right now. But this actually is true. Someone has questions for any of the papers before. Okay.
The data you use, is it AAS? So is it available?
As far as I'm concerned, it's not publicly available yet, but the idea is to be able to publish it. To be able to, at least at some extent, to be published, not only for the Navy or police, but any company that has vessels to be used. This is correct. It's not publicly available right now, but the idea is to be publicly available. That's the good thing to work with the sectors, because they have data that I don't have, and that's the funniest and strangest stuff that you can find. And that's some hard problems with this too. Some questions? But Danielle, you are with us? Juliana? Then for the QA, for the guy from the UPC, which is on screen. Danielle, are you with us? Danielle? Hello? Can you ask the question and then later answer for YouTube if it's not here? It will be recorded.
Okay. So first of all, thank you, Daniel, for your work. I like it very much. And some of your challenges is very similar to what we have here in Brazil. So I'd like to ask in the end of your presentation. Oh, hi. Hi. Um, at the end
Hello.
of the presentation, you talked about trying to provide some devices to the schools. And I would like to ask you which device, what kind of idea you have, like a Raspberry Pi or simple smartphones. What are the devices? What are your plans? What's the suggestions?
Well, well, in my country, they have a program named Todos Conectados. This program improves the students in rural zones devices like laptops, tablets. In this case, we try to provide the platform with laptops. We have in other cases, other students they receive the laptop, but they are missing their laptop. I have a problem with that. I try to provide other solutions like get give them the devices or other things to get. And other schools they don't have in the program, so only the teacher only gets the program gets that information. Try to obtain the data. Um, and with that data, show all the students in primary school the course and try to learn. They try to learn about that. So students really like it. I see well, very very happy about other things about that traditional learning.
Uh, we have some applications with Raspberry here, and I know about the happiness of the children because I have families that in my family there are people who works with that children with very vulnerable situations, and they really like it when we put technology in their hands. And here with Claudia in our laboratory, we have some good experience with Raspberry Pi. It's an affordable device to help children get in contact with uh, technology, but as in like a simple desktop, not a project of your IoT. Just take the Raspberry and transform it into a desktop. It's affordable, it's simple, and it attends the children necessities. So thank you, thank you for your work. And if I could suggest, the Raspberry project is the cool one.
Thank you, thank you.
Thank you.
Don't worry.
Thank you, Jesus. More questions to any of the authors, to Daniele or to Mateus? Questions from the YouTube people? Support, guys. No questions from YouTube. So we have still time, Juliana. So, guys, we can take a small break, like 5-6 minutes, for you to take a coffee and go to the bathroom before the next session. I apologize. I was in a hurry. I don't know why, but this format of doing all the presentations and questions at the end always makes me forget. And we have like more 2 sessions, paper session 4 and paper session 5. I believe most of those sessions, there's a lot of online presentations right now because there will be a lot of people from abroad right now. I think there is just one big that will be, the next session will be presented on site, but I'm not sure actually. So that's it. So do a small break and we come back in 10 minutes. Hello, guys. Let's go back. There will be a lot of this paper. We have some special conditions too, due to some people that is in Europe. So a little bit too. It's night up there. So people, for the first paper, we have the inspired methods and frequent approach for pattern classification like categorical and mixed data. That will be presented by Gabriel Matos. This paper will do the questioning right after, just because Gabriel it's late on Europe. And then we have multimodal future approach for enhancing master activity monitoring from Vinicius, that is here physically. So then we have contextualization of organization text documents from Rui Sarmento, Douglas Cardoso, and the latest multi-dimensional feature extraction for the identification of online harm spreaders from Daniela Godoy from Argentina. So thank you for all the speakers. Gabriel, we are doing this. You will present, and then we will ask you later. Okay?
Okay. Can you hear me?
Yeah.
It's perfect.
Okay for this?
Okay.
So we have 10 minutes, and then we will make some questions. Thank you.
Okay. So thank you. Thanks everybody for the amazing conference, and also for the initiative, and also for allowing me to present my paper. So I'm a PhD student at PESC, and then my advisor is the Professor Carolina and Carlos Pedreira. So I'm presenting here a paper, as Claudia said, it's based on Biospire methods in a fusion approach for pattern classification on the categorical and mixed data. And I also forgot to mention that, as Claudia said, it's night here because I'm here in Madrid as an exchange in the University of Alcalá for my PhD. So I'm going to start the schedule. I'm going to start with an introduction on how it is important and why we chose to tackle this problem. And then I'm going to give a brief overview about what encoding is and what are the common methods to do encoding. And then I'm going to go through the contributions of the paper and also the results. And I'm going to finish with some conclusions. Okay, so the problem here is that with the increasing amount of data, especially from several sensors, from user data, from any source, predicting the outcome of new unseen data, it is still a challenge. And what is also a challenge within this is that many of the data, they contain attributes, so the features that there are in data, that we usually treat them as numerical, but we should be treating them instead as categories, so as categoricals. And a major problem is that the baseline machine learning algorithms that we have, such as SVM, KNN, and so on, they are originally designed for numerical data. So, for example, algorithms based on distance, so we cannot calculate the distance for a category. So we need to adapt or we need to change something. So one way to allow these baseline algorithms to be employed on data sets that contain features that are categorical is to encode these data into numerical features. So there are two main goals here in this paper. So the first one, we had analyzed the behavior of different encodings. And the second one, we had analyzed the performance of, we have generated 5 couplings between 5 different traditional algorithms and an encoding technique. The first one, sorry, I'm gonna go on. So what is encoding? So encoding, we have categories and we are interested in transforming these features into numerical features. So we are interested here into features that contain nominal and ordinal values. So nominal values such as gender, or ordinal values such as preference from a user. So it's you can say like it is bad, neutral, good. So there's an order inside. So we had analyzed 3 different encoding techniques. So the first one is the most naive one, which is called ordinal encoding, in which we just assign an integer value to the categories as we see them. So this is a main drawback, that it introduces an artificial ordering. So imagine we are encoding preference values, and then we could say that neutral is 2 and then good is 0. So we are introducing an unwanted ordering. A second one is the one-hot encoding, in which we encode each category as a vector, but there is a problem here, that as we have high attributes with high cardinality. So imagine an attribute in which we have several possible categories. It would generate an extremely high dimensional data matrix. And considering that a data set in which we have a lot of attributes, treating this type of data would become a problem. And then we focused our analysis on the one that is called target encoding, that addresses these two drawbacks by encoding the features using the class labels besides the data, the categories distribution. So what is this encoding? So for each feature that should be treated as a categorical one, we create a column for each possible class. So for a binary problem, we would end up with, for each feature, with a R2 vector. So each value is a convex combination between the posterior probability of the class label given the category value and the label prior. So a quick example to understand this, given that we have a category, a feature for size with possible categories as short, medium, and tall, and we have a binary problem in which we have 20 samples for class 1 and 30 samples for class 2. We have 20 samples with category short, in which 12 of them belong to class 1 and 8 of them belong to class 2. So the encoding would be an R2 vector in which we have do you see my mouse or no? No, sorry. So how do I change this? Okay, so we have the posterior probability combined with the label prior for each label. So we have a binary problem, we have an R2 vector. The problem with target encoding is that this lambda function is based on the class variance. And usually the class is also a nominal value. So imagine the class is risk or not risk, good or bad. This is a nominal value, and the variance is not defined for nominal values. So one of the contributions is that we modify the target encoding to use entropy. So we don't rely on any numerical mapping for labels, and we rely only on the empirical probability. So we remove this drawback. And then once we have made this modification, we have assigned 5 different couplings in which we have a baseline machine learning algorithm that goes from MLPs. This one's called neighborhood component analysis. This is a stochastic version of KNN, and then we also compare it with the original KNN. And this algorithm has a mechanism inside that optimizes the error using gradient descent. So we have made a second one, in which we replace these mechanisms by an evolutionary algorithm. So we are also comparing a traditional machine learning algorithm that uses an evolutionary alternative as optimizer, and SVMs as well. So we make pre-processing using target encoding, and then we feed this data to these algorithms. We have used 3 mixed and 5 purely categorical data. So mixed means that data has not only continuous features but also categorical ones. And then we have made 10 independent runs using tenfold cross-validation to measure the error. So the data sets that we have range from extremely low number of features to extremely high ones, and they are mainly binary. There's one that has more than 2 classes. So for this one, we have used a technique to as one versus all by voting, because many of these algorithms are inherently binary, and the number of attributes also vary. So there are this one with a lot of attributes, some with very few, and we try to cover a wide range of configurations. And the results, okay, so as expected, most of them are the performance in most of them are the best one is from the MLP. So it is, well, it's expected to be as good as the other ones due to the generalization ability. But one thing that also called us is that the version of NCA using CDIPSO compared to the one using gradient descent improved the results in most of the cases, except for the dataset 6. All the other ones we had improved the performance. So although we hadn't achieved with this algorithm the best performance on all datasets, we had improved the performance compared to the one using gradient. And as well, SVM did not perform as good as the other algorithms. So there might be something that we need to investigate a bit more, but there might be something with the structure within how the SVM does find the separating hyperplane, that when even though we have encoded these categories into numerical values, it also worsens the SVM performance. So to conclude, as I was saying, we were able to outperform the standard NCA in this categorical classification setup using an evolutionary approach. So this is extremely good because we have a wide range of meteoristics. So there is CDIPSO, but there are other ones that differential evolution, particle swarm optimization, that these results leads to us to investigate, like, okay, what if we can improve other algorithms that are based on gradient optimization by using some evolutionary method. However, we were able to obtain a good performance with this coupling, but not on every case. So the targeting coding with the multi-layer perceptron turned out to be the most competitive approach. But we have with these results indicate that it is important to carefully encode, to carefully treat the data before performing any type of classification task, not just feeding the data into an algorithm without making some smart pre-processing that takes into consideration the type of the features that there are in this data. So thank you for your attention. And these are my contact emails, and thank you for the opportunity.
Guys, we can just change it because it's too late in Spain. I guess it's around 8 o'clock, 9 o'clock. So, if you have any questions for Gabriel that you want to ask, okay, please. Just be a really small question, but just have 5 minutes.
Okay. Well, thank you for your work. And I would like to ask if you considered for future works to use this kind of encoding technique with wizards, the weightless neural network.
With what? Sorry, wizard.
If you have considered in future works to use this technique and test it with weightless neural networks. We have talked about wizard here during the day, and I think the network. So
Okay.
the wizard, the weightless neural network.
Yeah, thank you for the question. Well, it wasn't on our map, but it is some of the possible future works that arise from this work. And it's just your question is very good because it is just one of the possibilities that we have from this. This is something that opens up a path for a lot of different works based on this. But it wasn't on our map to work with Wizard because I know that they perform very well. So it is something that I'd like to go a bit more deep into. But I don't work with Wizard a lot. So it wasn't on our map just because of that. But I know that they perform very well, and then it's something to try on.
Much. Thank you.
Thank you.
Some other question? Someone YouTube too? No? Yes? No. So thank you, Gabriel. Excellent presentation. I don't have time to pass for the next presentation. This is from. It's an on-site presentation right now. That is multimodal fusion approach for enhancing vessel activity monitoring. Vinícius do Nascimento, Thiago Alves, Diego Dutra. Vinícius PhD student. I was in committee. I was on the okay. There's a funny story. I was in the Vinícius committee during I was in an airport trying to do my best. Hope I did, but it was fun activity. That's
Can I? Hi everyone, I'm Vinícius Dalto. I will present about our work, multimodal fusion approach for enhanced vessel activity monitoring. Well, I talk about briefly about some contents, an introduction, motivation, objective, the proposed architecture, and some remarks about in the conclusion. Well, the maritime domain is huge and replete with a variety of the activities, ranging from the legal trade to the illegal activities such as illegal fishing, smuggling, piracy, environmental, and so on. And it's critical to accurately detect these vessel activities in order to ensure the maritime safety, sustainability, and governance. So these maritime authorities need to detect and address appropriate action against these illegal activities in a timely manner. Maritime authorities in the world can be represented by the Navy, Coast Guard, and other institutions dependent of the country. So these maritime authorities need to monitor thousands of vessels daily, and most of these maritime authorities uses maritime situation awareness systems based on behaviors or kinematic rules, and usually this system needs to help by a specialist. In case of detection of illegal activity, the maritime authorities may take a decision to inspect this vessel. So in a situation of naval inspection, several resources can be allocated, like navy ships, crew, environmental inspectors, drones, and others. So a false positive can be expensive. And vessel active detection must have a high reliability because a single mistake in its predictions can costly for the maritime authority. So our motivation must work in literature present approach that don't use the context in the situation and the text vessel behaviors. Few works in literature address the vessel active detection. Most of the works address just vessel behaviors. It's important here to concept this vessel behavior and vessel activity. Vessel behavior can be detected by sensors. Sensors like AES, radar, cameras, satellite images. You can observe the vessel. In the vessel activity, a human can use a vessel for practicing activity. So in case crime, the commander of the ship can commit a crime, a crew, the owner of the ship. So it's very important to have a context here. To detect a vessel activity, we need to detect an ensemble of vessels. So we need to detect, we need to have the context of the situation. So in this case, the specialist is very important to define this context. In MSA system, the specialist can create some kinematic hues based on their knowledge. So the specialists need to deal with thousands of different daily, but the main goal of the specialist is that that's the vessel activity. But the specialists need to deal with the thousands of alerts and behaviors of these vessels and analyze each case of each vessel. So in this context, how can combine these behaviors with specialist hues for detecting vessel activity? And how can we decrease the number of interventions of these specialists? For this, we propose an architecture where the detection is centered on the activities instead of behaviors, which this can significantly reduce the operating interventions. So in our architecture methodology can combine this data-driven detections with the knowledge-based approach, granting a contextual grasp of maritime scenarios. So we have a problem here because we don't have labels for some activities. We don't know what is illegal fishing, we don't know what is smuggling. So in this case, we need the assistance of an expert. But the time of the expert is costly, so we need to optimize them. For this, we use active learning for that. Our architecture is designed to real-time and online detection because we receive data from the sensors, and our architecture can support parallelism, both during the training and the inference stages. Well, in order to achieve this desired objective, we will use a multimodal fusion to combine severe behaviors and the specialist rules and data from the sensors. And to solve the problem of the miss of labels, we use the active learning. Well, here we have a simple example of our architecture in an online example. Here we have the models trained. In the first picture, we have a vessel inside a bound, in a monitored bound. In the coastal, we have some sensors like AES, radar, cameras, or satellite. And these sensors can capture the vessel trajectory inside the bound. So we can pre-process this data, so this data can be used in the vessel behaviors. Vessel behaviors can be, for example, anomalous navigation, fishing trajectory, AES spoofing, loitering, dark ship activity. So we can several kinds of behaviors of vessels here. And we have the rules created by the specialist. So we can apply this data from the sensors in this model. So we have output here. So the main idea here is combine these outputs in a meta model where we can use multimodal fusion. So now we can predict the vessel activity. Here we put a threshold to avoid trash to the specialist. If the threshold is achieved, a message can be shown to the specialist. The specialist can analyze the vessel and confirm or correct the prediction of the model. After that, we can store this response of the specialist and the model prediction for further model update. Here we have detail of this architecture. We have two levels here, the first level process and the second level process. In the first level process, we basically have the historical data of the vessel movement. And we can use this data for training our vessel behaviors. And we have the specialist rules. After the training of these behaviors, we can receive data from the online sensor, and then we can infer this data. This data can be used in the second level process. In the second level process, we have the metadata. In the beginning, we don't have labels here, so we need the help of the specialist, and the specialist can set some labels like a cold start, and then we can train a model with this data initially, and then we can use the data from the first level process, and then we can infer the vessel activities. So we have a threshold. If the threshold is achieved, acknowledge based, the specialist can confirm or correct the response. And then we can save this data on this expected knowledge base for further model updates. Well, some conclusion here. Literature, a small number of studies addressing vessel activity classification. And here in this work, we present a change in focus from just detect behavior. Here we present to a more complete classification of activities, and our architecture can enhance the maritime monitoring process and decreasing the number of interventions of the specialist. A combination of models based on data and expect here to give a context of the maritime situations. For this, we use a multimodal fusion and approach for combining these models and data. Our architecture can support real-time online detection, parallelism, and it's important to be scaled because in the future we want to increase the number of activities to be detected, and we want to increase the number of behaviors to enhance the performance of the model accuracy. So in the research, we should be looking to more deeply to implementation of this architecture, as well as using approach incorporating larger sensors and data streams. Thank you.
For the next paper, we have the contextualization of the organization of text documents and streams. The authors are Luiz Sarmento, Douglas Cardoso, Pavel Brasil, João Galvão. I believe this is also an online presentation, so bring it on.
Good afternoon.
We are listening, but not viewing. Okay, viewing you. It's
Good afternoon to you all. Thank you for your time. I'm Rui Sarmento from Faculty of Engineering of University of Porto, and I'm here to present a paper about the contextualization of document streams for their organization and analysis. So I'm going to do a brief explanation about what was an initial prototype. Then I'm going to talk about the organization of document sets and the use of several algorithms that were developed and updated for the streams of influx of text documents. I will talk about the incremental similarity in text streams, which is important for the aggregation of similar documents in the flux of text documents. And then I will talk about the main concept in this paper, which is the contextualization with word embedding. And I'll talk about, of course, the results and future works. So we had a prototype and to organize large amounts of documents, text documents, and this could be useful for several concepts. So, for example, or context, marketing, customer relationship, technical documentation, logs from servers, telemetry, and they need to be analyzed and to support decision making. And of course, this has to be done in real time to be a significant resource for a better decision support. So what we need better organization of large sets of documents, more efficient methods, and ability to cope with changing conditions. Or this is the updates that are occurring in the documents, for example, or the arrival of new documents in the stream. We had a static prototype, the affinity miner prototype, which was used in the research context with data from the researchers and papers from researchers, which had their keywords also, so they served as a ground truth analysis set. And we have the representation of documentation in the prototype with complex networks, where we could see the connection between documents. This is with each node is a document, and the connection between the documents represent the similarity between these documents. So we had community detection in this complex network, which could retrieve the communities naturally arising from the similarity of the documents. We could select communities. We could set the keywords for each community. We could see the distribution of the documentation for each department in the research data set. We could see some centrality also of the documents, which documents were more central to their community or to their aggregation. And we could also see in this prototype the keywords for each document individually. So this was an interesting experience with this prototype, but we had problems to scale, and we couldn't scale to larger sets of documentation, and it was a static solution. So it was not possible to update the data set that we had. If we could update, we would have to make all the calculations from the beginning, all the calculations for community analysis and centrality and so on. So we updated some algorithms, mainly incremental algorithms and incremental solutions from the algorithms that we were using in the prototype. For example, centrality algorithms, community detection algorithms, other algorithms were transformed. For example, the text rank was transformed to retrieve the keywords from the documents, and they were transformed to an incremental solution to be updatable with the stream and the flux of documents in real time. One of the algorithms we updated was the text rank algorithm, which is a well-known algorithm to do a keyword extraction, for example, and summarization. And we did an incremental approach, and we transformed the page rank implementation of the initial text rank to be incremental, and we have also the application of top K space saving algorithm to be ready to know which keywords are more important in the flux of the documents. So this works by having a notion of similarity between documents, so we can aggregate them, and we also know the keywords which compose each document, and this is changeable with time and with the flux, and we extract these keywords with the text rank algorithm. So this will be published, I think, the presentation. It has a lot of information here. I don't have time to talk about all this information. So I will briefly say that we have two different methods where we can use the incremental text rank. We could use the incremental text rank in a single document stream, where each document was a new document, was considered a new document, and the documents were not updatable. Each new document was a new document. And we also used other implementation of incremental text rank, for example, with several documents stream, which could be updatable. So a particular document could be updatable somewhere in time in the future, and it was ready for doing that, and it was always updating a top case structure for each document and its respective keywords. This is explained. The concept is around the occurrence of new words in the stream. So a document which was already present in the stream could be updatable with the arrival of new words or new keywords that were not present in the stream. So, for example, here we had a new node. It's a new word, and each new node is a new document keyword in the page-rank implementation, in incremental page-rank implementation. This allowed us to use also two types of implementation of the stream. We could use a window-based calculations, or we could use an incremental calculation, which was a landmark window. So we stored the data since the beginning of the flux, and infinitely we were storing the data. And we could use a sliding window approach, where we would slide the window in the flux, and we will discard the previous information, and would only use a little chunk of information for that sliding window time base. So we had some publications about this previously, and we also had another method involved in this paper, which was the incremental similarity TF-IDF and incremental cosine similarity, and we used it as another approach to have the extraction of keywords from flux of text documents. This is based on the concept of bipartite graphs and the concept of complex networks, where we had two types of nodes. One type was the document type, and the other type was the word type, the term type. So in this case, in the flux, we can understand this graph by if a new term appears in the graph, for example, car, and the document 2 has a new word arriving, car, the similarity would only be calculated, or the updated similarity would only be calculated for the documents that are connected directly to this document through similar words. This is important because this allows for a better efficiency in the calculation, and it's processing a lot faster, because we only update the similarity between documents that are somehow influenced by the arrival of new terms. We don't have to do the calculation for the global data set and the global nodes, only the affected nodes. So this document 2 was updated in the stream, and the only other document affected was document 1. So we would only update the similarity between document 2 and document 1 this time. This improves the efficiency. We could achieve very fast high speed up ratios. So this was a good way to do the organization of the document sets in the flux of streams. So, and we arrived to the contextualization. We were doing this with only the data that we had in our context of the data sets that we were using. So we thought, why not use the external contextualization to calculate the similarity between the documents in the flux? So we use the word embedding, and it presents less complexity than other algorithms. For example, the update of cosine similarity. And it is customizable because you can choose any type of dictionary we want for word embedding. And the only disadvantage is that can have it's that it might be memory consuming, considering larger word embedding dictionaries. But either way, we tried to test the IS-TF-IDF and the ITR, incremental text rank algorithms, with and without the word2vec, and arrived to the conclusion that, for example, IS-TF-IDF did not improve or decrease quality with the use of word2vec, but ITR, incremental text rank with word2vec, presented better quality in the clustering of the documents with the similarity, with the use of word2vec, and this presented a great improvement in the overall achievements that were already very good with the updated algorithms we have done in the past for this research. So I'm arriving to the conclusion. I don't know how much time. Yes, okay. Future work. We could do a subjective test of this with beta testing with an audience. Subjective points, the identification of target documents, for example, in an organized list of documents or some directory, or you could see if subjectively we could enable one to gain a better and faster understanding of scientific production of a given institution, for example, some university or faculty. And we could also approach the problem, a very complex and actual problem like the LLMs, so large language models, with the use of complex networks. Could we gain a more efficient and green solution with the use of complex networks? What will be the comparison of the generative model with the LLMs, but by using complex networks instead of neural networks? Why not? So this is the end, and thank you for your attention, and hope to hear some questions.
Thank you very much. Okay, so the questions will be at the end. So we should move to our next speaker, which is Daniela Godoy, with a multidimensional feature extraction for the identification of online harm spreaders. So Daniela, please welcome, and the floor is yours.
Yes, hello. Can you hear me?
Yes, we can.
Okay. Thank you very much. Thank you all and the organizers for all the efforts to bring in this community here closer to South America. I'm a researcher from Argentina, from Louisiana University. I'm from CONICET. And my work, the work I will be presenting today is an approach to feature extraction for the identification of online harm spreaders. We all use social networks and social platforms every day for a lot of things, to sharing opinions, communicate, to express our ideas. But unfortunately, also social networks are now flooded of low quality content and harmful content in many ways, which is generated intentionally or not by users. So it is important to not only identify the pieces of information that are of bad quality or that are harmful, but also to identify the people that is propagating this content online. So what we call online harm spreaders are users that are acting maliciously to propagate any kind of harm that could be fake news spreaders, hate speech spreaders, or rumors, or conspiracy theories, or any other kind of harmful content that can be shared, propagated, and it's important to identify these uses to mitigate the effect of this propagation, and to reduce its impact in the general social network. Usually, profiling these users has been seen as a binary classification problem, defined in a set of especially designed features for describing the users, specific for the type of a spreader. For instance, for fake news spreaders, there are certain features, and for identified haters, it's another set of features. So, and the classification is oriented to distinguish between a spreader and non-spreader of the certain type, or users counteracting their actions. For instance, fake news spreaders and fact checkers in the other side. And what I here presenting is a study that is oriented to define characteristics that distinguish diverse type of spreaders from their counterpart, and it's also tending to better understand each type of user and each type of spreader to identify them more clearly. So I find a large set of features that they are spanning multiple dimensions of analysis to represent the behavior of users, and tending to identify several type of harm spreader in general, like a general class of spreader. The hypothesis is that this dimension will be help not only to classify different type of spreaders, but also to characterize them better and trying to understand them better and use that to stop their actions in the social networks. So instead of restricting the problem to a binary classification focus on a reduced set of features, I define a more general representation spanning several dimensions, which I will enumerate now. And so they can be used to classify either binary or a multi-class classification of spreaders. So the main dimensions that I am mentioning is start for some basic tweeting activities and elements that people include in their tweets. I'm talking about tweets, but it is general for short text in social network. As for instance, if a tweet is a retweet or not, if there are how many hashtags tweets had a tweet, mentions, links to web pages, emojis. So from each user collecting their last tweets, these features can be extracted and start to describe their behavior and the content that they generate on the social network. After these basic features, there are also important differences between in spreads according to the way they write. So the writing style they use. This can be analyzed in different levels, from a lexical level, as how many words or terms they use. If they stretch words like wow or something like that. If they use capital words, which is common in for instance, in hate, or for emphasizing some word in particular. The use of punctuation is also important. The exclamation, interrogation, the ellipsis is important for detecting, we will see irony, for example. And that's the writing style and syntactic label can be with how many verbs, nouns, and other type of words people use. And as semantic label, we can link some words to certain semantic categories. Here I use some of them, like the ones denoting cognitive processes, for example, insight, causation, discrepancy. They all are tending to better analyze what is written in a tweet and how much people use that kind of expressions. Besides the writing style, we have, which is very important for identifying spreaders, is the use of emotions and sentiment. In this case, we are extracting emotions mainly from 3 different lexicons, which are emolex, that they have 8 emotions: anger, fear, anticipation, trust, so on. Also, liquid have a lot of a number of expressions that can be used. Of emotions that can be used to describe the content that the user generates. And in part, that is a lexicon that have many categories that that can be offer a wider range of emotions to analyze. For instance, politeness or sympathy. So here there are 75 features to describe emotions. So some of them can be overlapping, but in the long run, I think they are tending to correlate in the classification. For sentiments, I saw using only 6 features that are extracted from Vieira. That is, if they are positive, negative, neutral, or a compound metric that gives a single number. Also, stanza gives a single sentiment score that can be used, and also the sentiment that can be extracted from emojis. Finally, 2 additional dimensions that I analyze is the readability of the text that the user generates. How readable is for others. So this can be estimated based on different metrics that relate to text with a certain level of abstraction needed to understand it. You know, here there are some of these indices that can be used, and also the lexical richness of a user, how much vocabulary they use, the diversity of the vocabulary, and which can also be estimated from by different metrics. These last 2 dimensions are used considering all the last tweets of a user. It's not a test-wise approach. And okay, with all these dimensions, what I'm intending to do here is to explore how if which of them are important for each different type of a spreader, which varies according to the spreader, and if with this wide broad number of features, we can classify different types of spreaders. So for that, I use 3 different data sets to evaluate the approach. The 3 are obtained from a short task that is annually. It's an event that is takes place annually, and every year they release a data set of spreaders. The first was a data set of fake news spreaders. Then 2021 they released a data set of hate speech, and the last one was about users that spread irony, particularly towards certain stereotypes. So the three are kind of they are balanced data set. They are annotated by users, and in each data set we have users that are regular users and spreaders of each of the types of harms, in this case fake news or hate or irony. Well, we come first observing this in this image that is for fake news of the fake news spreaders data set. We can see the different dimensions of analysis, from the basic to the lexical, syntactical, semantic, reaction style, emotions, sentiments, and readability and richness. And this is the mutual information of each feature for every dimension. We can see that there are features that have very low mutual information, or many have zero mutual information, that they are not useful for identifying spreaders from non-spreaders of fake news. And there are layers also that seem to be very important to distinguish this kind of spread. For instance, here we have that in average, for example, richness seems to be an important dimension for identifying spreaders, followed by sentiment in general terms. What is important, this is varies according to the type of, different for each type of spreaders. You can see the same image, but for hate speech spreaders, we can see that sentiment seems not to be so important. And basic features, the 5 basic features from the beginning are a little more, in this case, important. And here we can see from irony spreaders that also there is they vary in their results. Okay, here, for not taking so long, there is which is the top 10 of features related to emotions. We can see very quickly. We can see that for spreaders it's an important joy, positive emotion, anticipations. Instead, for hate are all negative emotions like hate, sadness, and rage. And irony are less. They have a non-spreaders are more have more emotions or show more emotions than non-spreaders. Finally, we consider the classification result for different classifiers. We can see that using every subset of features, the result of a classification, and in general terms, using all features, we can classify. We got the best result in this case for fake news spreaders, and here is more. The results are more varied, but also best results are here when use all the features, and that is what happened also for irony spreaders. So using all the features, we can get really good results. Here is a summary of the numbers. And for concluded, we can say that there is a broad set of features that allow us to classify the 3 types of spreaders instead of focusing on small branches of specially defined features with good performance. And we will explore more of these characteristics to try to characterize better the spreaders, and to understand and to lately to stop their actions tending to stop their actions on social networks. Okay, that's all. Sorry if I take too long. Thanks a lot.
Thank you very much.
Thank you.
So we have time for a question. Any questions for any of the 4 presenters? No? So thank you again. And we move to session number 5. Yes. So for session number 5, okay, maybe it should last. The first presentation is online. Okay.
Hello, can I present?
All right. Oh, yes.
Okay, so my presentation. Thank you. So my presentation is about advancing smart forestry with information fusion, and we also consider it in local context in Latin America. I'm Robertas Damascevičius from Kaunas University of Technology, and also you can see on screen my co-author, Professor Rytis Maskeliūnas from the same university. So, first of all, we would like to start from one of the most important problems faced by global forests is deforestation. So large-scale removal of forest cover, which is a critical global issue with far-reaching environmental and social and economic impacts. First of all, forests are known for biodiversity. So when you cut forests, you decrease the amount of species in nature. Also, forests are significant carbon sinks, absorbing CO2 from atmosphere. So when you cut the trees, this carbon is released and it contributes to global warming. Also, deforestation has serious social impacts because many communities rely on forests and their products. Also, deforestation, although it might provide in short-term economic benefits, in long term it leads to some economic losses. Here you can see the most important causes of deforestation. The deforestation is mostly caused by agricultural expansion. So when people plant some products, we usually cut the trees to clear the fields. Also, illegal logging is a very serious problem for timber and also for paper. Infrastructure expansion of cities and also villages contributes to deforestation. Also, such activities as mining and oil extraction also contribute to deforestation.
And I would like to supplement that now we also have a political factor in this, because in Europe, regulations now require us to cut down some forests and regulate national lands. In Lithuania, we have cut multiple batches to create dunes. And unfortunately, for this globalism-inspired scenario, this further increases deforestation, even if this relates to the climate change agenda, as Robertas has been saying.
So this problem is also very serious in Latin America. You can see on the map, especially in Brazil and Argentina, where large amounts of forest have been lost due to the reasons mentioned by me previously. So mostly agricultural expansion, logging activities, infrastructure development, but also climate change, because climate change also leads to forest fires, and a lot of forests are lost to the wildfires. That's why the so-called smart forestry is important, because in recent years the forestry practices have evolved significantly from the traditional or classical methods to the methods which use information technologies, but also artificial intelligence, Internet of Things, remote sensing, and drones. And using these practices, a lot of activities can be done to save our forests, both globally and locally. Related to smart forestry is a concept which is called Forest 4.0. Actually, you can trace the origins or roots of this concept to the so-called fourth industrial revolution, which brings in tools like big data, Internet of Things, artificial intelligence, and so on to transform industry and our lives. And here, in this case, we have the same tools which are bring to transform the forestry practices. The most important things which allow to improve and optimize forestry management is data which can be collected from a variety of sources, from satellite imagery, also from sensors on the ground, using sensor networks. And this data can provide valuable information about forest health, about forest growth patterns, also environmental impact.
And we also, yes, we also need to mention the data management part. For this, we applied blockchain-based methodology to handle supply chains, and experiments and practices already proven that this concept, together with smart data handling and collection, can have a very significant transparency factor in modern forestry.
This data can be collected and then it can be analyzed using artificial intelligence methods to provide valuable insights on forests, which are very useful for the conservation of forests and also restoration of forests in case of degraded areas and also illegal logging. Also, it allows for real-time monitoring and action using Internet of Things to react to environmental changes, to wild forests, to various pests and disease outbreaks, which can affect negatively the resilience of forests. On this slide, you can see the example of Forest 4.0 system implemented by Komatsu. It's a Japanese company which has developed a smart forestry system that allows for more efficient and sustainable wood harvesting, and it integrates advanced technology using cameras, laser sensors to create three-dimensional maps of forest areas. So it's a good example of integrating advanced technology into forest management. The three-dimensional maps generated by the system can be used to plan most efficient paths for harvesting machinery, which allows to save the forest cover and other types of forest plants. And
we can say that it's not only more efficient, but also more transparent and, more importantly, faster in operation. It brings all the benefits versus the classical timber processing. So they immediately know viewing the forest and already know what will happen with the timber cut down. And all of this happens much faster. The whole process is faster compared to traditional paper-based forest process. And this was already tested.
So such practices also contribute to the sustainability of processes in forestry domain. Also, information fusion plays an important role in forestry because it involves integrating data from multiple sources such as satellite imagery, ground sensors, also historical data to provide a holistic view on the state of the forest. And it's very important also to predict in future forest health and dynamics. Also, it is important for providing enhanced decision-making for forest stakeholders by giving them informed decisions and comprehensive understanding of forest dynamics. For example, if you combine satellite data with ground reports, you can help in assessing the damage after wildfires or after storms, and also planning necessary recovery actions. Also, the fusion of historic and real-time data enables predictive analysis, such as forecasting of disease outbreaks and also identifying areas of high risk of wildfires. And this integration of data allows and provides customization and flexibility for local needs and challenges faced by local forest communities. In the forest data, the traditional information fusion processes and techniques can be used, which involve data processing, feature extraction, data association, also modeling using various methods, both from machine learning and probabilistic modeling. So this type of processes are explored by the project, which is managed and executed by a consortium of 2 Lithuanian universities and also
Yes.
Swedish university.
Together, basically together we cover the whole forest of Baltic Sea region, which is the larger producer in the area. So this gives us a platform, ERT-enabled platform, to test and validate all the approaches presented here. So we become like a digitized platform to combat all these problems that we have in the region. And this is becoming especially important given the latest policies and regulations. And also we are very happy for joint collaboration with your colleagues from Latin America, because you also have the same problem. So we can jointly apply these techniques in our research.
So, summarizing our presentation, the Forest 4.0 approach is a transformative approach for forest management, because it integrates advanced technologies like Internet of Things, artificial intelligence, and also big data, and it represents a move towards more efficient, sustainable, and data-driven forestry practices, and also has great implications for solving various real-world problems, such as climate change mitigation, and also proceeding towards more sustainable work practices in forestry. Any questions?
Yes, thank you.
Thank you. Any questions?
Thank you very much. So we move then to the next presenter, which is Andrea Mori, Júlio Tesolini, Marcos Silva, Davim Moura, and Professora Maria Claudia Cavalcanti, implementing very hierarchical restrictions in communications applications. So, Andrea, the floor is yours.
Thank you very much. So, hello, everyone. My name is Andrea Mori. I study at Military Institute of Engineering, and I will present our paper entitled Implementing Military Hierarchical Restrictions in Communication Applications. So this is a brief structure of my presentation with these 5 topics. I will start by the introduction. So we are proposing an approach to help in the decision-making process in technologies such as cognitive radio, software-defined networks, and we are proposing an integration of these technologies with the tactical communication networks. So this integration could allow these technologies to make decisions not only based on the spectrum, but also related to the tactical environments. It is not only decisions about the signal level or the network, but also about the military environment. In light of this, we introduce an ontological model to help in the decision-making process. The main challenge of this paper was the use of conceptual modeling that's based on conceptualizing from a foundational ontology namely the UFO, the Unified Foundational Ontology, the use of web ontology language, and the use of rule definitions expressed in the semantic web rule language. In the background, I will talk about the main themes involved in this paper. So the first one is the semantic web. So here we have a figure of the semantic web stack with some semantic web layers. So the semantic web provides representation in the reasoning resources, such as ontologies and formal language, that are useful to represent the military communication scenario. So we are proposing to use the semantic web language to create operational ontologies, operational machine-readable representations of the military communication scenarios. So these files can be used by technologies such as cognitive radios to make decisions. So the information about the decision will be in the ODBOL. So we are using languages such as ODBOL, RDF, XML, and we are implementing our operational ontologies using the semantic web language. And the operational ontology is an implementation of the reference ontology. So we are implementing our reference ontology using the unified foundational ontology. So the use of foundational or upper ontologies in conceptual modeling attempts to produce richer models and representations with fewer problems of interoperability and ontological incompleteness shown in open and dynamic scenarios. And we chose to use part of an ontology development called SABIO, Systematic Approach for Building Ontologies, which reinforces the use of UFO and distinguishes between two types of domain ontology, the reference and the operational ontology. So the reference ontology is a domain ontology with the purpose to make the best description of the domain. And we are using the conceptual modeling to develop this reference ontology. And the operational ontology is an implementation of the reference ontology, and we are using the web ontology language to implement the operational ontology. And to implement our conceptual modeling, we are using the OntoUML. That is a language based on the UFO proposal, and is an extension of the UML, and it has the anti-pattern detection that helps us to follow the UFO theory and the UFO rules. And we want to implement in the operational ontology restrictions on communication on a military network. So we have here one example of a military network with some nodes, and we have restrictions based on the hierarchy. So to one node to talk with the other, they need to have a subordination or a commander relationship in the military hierarchy. So this is an example based on a real environment, on the real world. So we want to create this type of restrictions in our operational ontology that can be used by cognitive radios or simulators of the military communication scenario. So I will talk now about the reference ontology for military operation scenarios that we developed. This is MISCON, the military scenario ontology. But in this paper, we are focusing in this fragment of the ontology that is about the communication restrictions. So this is the fragments of the ontology. We have here represented the military person, the military organization. They have a relationship, a material relationship. The military organization can be a subordinate or a commander. They have a relationship of subordination. The military person operates the user equipment up and the user equipment down. The user equipment up is to talk with commanders, the user equipment down is to talk with subordinates. But here we just have the conceptual model. We don't have the restrictions implemented in our operational ontology that can be used by these technologies. So I will talk now about the implementation of the operational ontology using the semantic web rule language. So we use the ODBOL, the RDF, the semantic web rule language. So first we developed our conceptual modeling using UFO, OntoUML in visual paradigm, and exported in RDF format to Protégé, and using the palette reasoner. And we developed our semantic web rule language inside the Protégé. So here we have a fragment of the ODBOL. we have two user equipments, and they have the relationship may talk to, and here too. So we are defining restrictions on communication between user equipments, since they can only communicate with others if the may talk to relationship exists between them. But how we created this inference using the reasoner palettes. So we created it using the semantic grab rule language. So we have the consequence of the rule and the antecedent of the rule. So to create an inference in communication, we need to have two military persons, two user equipments. The military person needs to operate these user equipments. We have two military organizations. One military organization is subordinated to the other. The military person has a relationship with this military organization, and if all these instantiations and relationship exists, so we have the inference may talk to. So this is an example of how we are creating the decision-making process using the operational ontologies that can be readable by technologies such as cognitive radios, software-defined networks, or simulators. This is an example that we show it in the paper. So we can conclude that this work reinforces the use of semantic web technologies to provide resource sharing and information fusion in military domain. In this way, the reasoning is generated in a machine-readable format, in an OWL XML format. Technologies such as cognitive radios can use these documents as an enforcement mechanism to make decisions. And we are currently exploring the application of operational ontologies in military operation simulation and network emulation systems. And in the future, we can explore cognitive radios and C2 applications. Here's some reference. Thank you.
Thank you very much. So we're ready for the next talk. Right, so we don't see the slides yet. I think, yeah, it's... Right, so the talk is about mapping the invisible, a framework for tracking COVID-19 spread on college students with Google location data. By the authors here, then we have Luis Capretz here, but we see you, Luis, but we do not see the slides there. We just
can you see the slides?
We cannot yet.
Oh my God.
Okay, we see now, and we see you, and we hear you. So the floor is yours. Thank you very much, and welcome.
Okay. Well, first of all, I was supposed to be in Brazil yesterday, but I got stuck in the US. So I'm doing this presentation from Chicago Airport. And I'm sorry about the noise nearby, but I'll do my best to be clear when I talk. Second, this work was done when I was on sabbatical in Malaysia with a few collaborators there. So although I am presenting the paper, the bulk of the work was done by people in Malaysia. So they asked me to present because in Malaysia now it's 3 a.m., so they said I should go for it. Well, we all know that how COVID was disruptive for schools and any education institution, right? So this system is about a automatic system to track people's movement and try to predict the spread of COVID. There are models out there, particularly the Google API that keeps track of people's movement. Okay, and we got the consent from 50 students on campus to allow us to keep track of their movement during 14 days, and then we knew where they were, and then based on another model of COVID spread, the model is when you are susceptible to get COVID, when you are transmitting COVID, or if you had COVID. So all of these models exist. We did not come up with anything new. What we did was collecting data using the technology that is available, and so that we can see how COVID was spread on campus. Okay. So again, as I said, there are direct contact model, indirect contact model, and we made use of the Google tracking movement to see where people are. So what the system does is automatically these movements are collected and stored in a database for 50 students, and we know every minute, every second where those 50 students were. So it's a lot of data, a lot of data point, but it's automatically collected by Google API and stored in a database. So the idea is, at certain point in time and for a certain number of minutes, we knew where these students were. Okay, so the Google API give us the latitude and longitude of every student, and we can say, oh, particularly in one day from 10 to 10:30, who were in certain places, and if we detected that the group of students in those places, if they were 1 meter apart, and if any of them was infected, then we could predict how many others would be infected. Okay, so that's the whole idea about the system. So again, this slide exemplify. Now, if you have 2 students, we know exactly if they were less than 1 meter apart at a particular time in a particular day, and then if one was infected, we could alert the other ones. Okay? Again, if it was a group of people, we could mine the data as well, because we have their locations, we have their time, and we know if one was contaminated or in a stage of spreading the virus. We knew that others could potentially got infected, and we could alert them. So, the mining, because we have this wealth of data, the mining was pretty much simple. We could predict on campus where most people stayed and where most transmissions took place. Okay, we could select anywhere in a Google map and see in a particular day and time who were there. Again, this is the API from Google, but there are models from the medical people that tell us if someone never got COVID, if someone was infected but was not transmitting, if someone has already got COVID, so how the spread would happen. Okay, again, we used those models so that we could predict the COVID spread on campus. Okay, again, at any point in time, we could know where people were and try to predict how others were infected and alerted. Because you remember at the beginning of the pandemic, there were not tests for everybody, no reliable tests. So we would focus on testing people who were most likely to be in contact with another people who were infected. So in this sense, the model was very valuable. Now you can ask me, but no, COVID is gone, so we don't need this anymore. That's correct, but we never know. In the future there may be other pandemics, but this model can be used for instance, to predict the spread of flu or other virus that may be predominant in a particular campus or particular city. Okay. Again, what we did, we developed a software system that we could ask questions about, who were in certain places, who were with you, and alert those people. Again, we did not invent any model for transmission. We did not invent any model to calculate the distance. We had the data from Google, and we just use that and put in a nice interface like you are seeing here. Okay, so the main conclusions of this work, we used a graphical user interface that used the Google History Location Extractor that facilitates the knowledge about the movement of people. We integrated that with a medical model for disease virus spread, and then we could identify who were at risks of being spread and test them. And as a future, with this model can be fine-tuned for other types of pandemic or even flu, because it's just a different model of spread. Okay? And with that, I finish my talk. Thank you very much.
Thank you.
Shall I kill?
Thank you very much, please. And we now move to our final paper. It has the honor to be the final paper of this day. It's optimizing the topology of wireless sensor networks with multiple sources and destinations. And our speaker today is Albir Jr., who's we see you. You're still in mute. We don't see your slides yet. You're still muted. I'll need just check whether your mic in the interface.
Oh, can you hear me?
We can hear you now.
Oh, okay. I'll share the screen here. So
I can hear you, see your slide. So the floor is yours.
okay. Good afternoon, everybody. My name is Almir. I am a doctorate degree student and a systems engineer in computer science program. And this work was done in partnership with the Computer Science Postgraduate Program from Federal Center for Technological Education of Rio de Janeiro. I'm from Federal University of Rio de Janeiro. And it is entitled Optimizing the Topology of Wireless Sensor Networks with Multiple Sources and Destinations. So we have a brief introduction, the definition of the problem, the methodology applied, the experiments, the results, and finishing with the conclusions and future works. So, wireless sensor networks are ad hoc networks for data collection, processing, and communication, and they can be used for environmental monitoring, military application, biometric data monitoring, and they can also be used as infrastructure to Internet of Things. And in this context of Internet of Things, there are two crucial aspects. Improve communication while saving energy, because sensors typically have limited energy, and the network topology, aiming to reduce the number of sensors required to cover an area of interest. Our paper focuses on this second aspect. So the wireless sensor network planning with multiple sources destination problem aims to minimize the number of sensors in the topology while accommodating multiple sources and destination sensor nodes, ensuring end-to-end connectivity between each pair of source-destination nodes. And this problem can be represented as a set S of sensors, each with a set of possible positions, a set P of source-destination pairs, given that for all pairs P, every source must communicate with this destination, directly or through hoops in the network. So for our methodology, we need to first define an artificial graph that will be used in the model and define the integer linear programming model for this problem. To define the graph, we first need to create vertices for each of the possible position of a sensor. So here in this example, we have 4 sensors, each of them with 4 possible positions. Another thing we need to do is to define the source and the destination sensor. Here in this example, the source sensor, the source sensor is the sensor number 1, and the destination is the number 4. For each source or destination sensor, we need to create an artificial vertex representing them. So A1 is representing the sensor 1, and A4 here is representing the sensor 4. The third step is to create edges between every position of different sensors that can communicate with each other based on its communication radius. So here, for example, the topmost position of 1 can communicate with the left position of 2 and the bottom position of 2, the possible position of sensor 2. The last step is to create edges between the artificial vertices we created before and the nodes they are representing. So A1 has edges to every possible position of sensor 1, and A4 has edges to every possible position of sensor 4. The last step is to redefine the origin and destinations to the artificial nodes, to the artificial vertices we created. About the model, in this study, the cost to deploy a sensor is equal to 1. So here we're aiming to minimize the number of sensors deployed, subject to some constraints. The first one ensures that there must be a path between every pair of source and destination nodes, source and destination sensors. The second constraint ensures that a sensor can't be placed in two positions of this set of possible positions. It can only be placed at most in one position. The third and fourth family of constraints ensures that for a node I communicates to a node J, both of them must be selected to be deployed. And the 50 family of constraints ensure that every artificial node we created must be in the solution. The last two family of constraints are about the domain of the variables that are both binary. The experiments were conducted in a computer with Intel Core i5 2.3 GHz with 16 gigabytes of RAM. It was developed in C++ and compiled with GCC 930, and the solver used was the IBM Simplex. The instances were based on real topology from Intel Lab data. This image below, where each hexagon represents a position of a sensor. So we created 4 scenarios, grouping the sensors in groups of 2, 3, and 6, and the number of source destination pairs in 2, 5, and 10. The execution time of the experiments was around 0.5 seconds, so almost instantly. And here we have the results in each of the scenarios. The first one, with 2 sensors per group, meaning that a sensor have 2 possible positions to be placed, and 5 pairs of source destinations, had a reduction from 27 to 14 possible sensors, a 48% reductions. In the image below, we see the results. The red hexagons means the places that was selected, and the group shows the possible position of each group of sensor, let's say. The second scenario, keeping 2 sensors per group, but now with 10 pairs of source destinations. And there was a reduction from 27 to 20 possible sensors, almost 26% reduction, as you can see in the image below. The third scenario, we have now 3 sensors per group and 5 pairs of source destinations, having a reduction from 18 possible positions to 10 possible sensors deployed, 44% reduction in the total number of possible sensors. And in the last result, we had 6 sensors per group, a bigger set of positions, and 2 pairs of source destinations, reducing from 9 to 7 possible sensors in this result, in this instance. So, a variant of the wireless sensor network planning with multiple source destinations problem was proposed, and also an integer linear programming model for this problem was proposed, and this model was evaluated using instances generated from real topology. The proposed solution optimized the number of nodes in the network, as we could see in every instance tested, and the solution maintained end-to-end connectivity between sources and destinations. And with this reduction in the number of nodes, it implies reduction in data traffic in the network and balance in energy consumption. So for future works, following a natural path, we should determine from what network size the model becomes inefficient, and then propose heuristics to solve those largest instances, these largest networks. So that's all. Thank you for your attention, and good night. Good evening.
All right, we have a time for questions related to our papers of the session. So, any questions?
Yeah, hi, me. I don't know if I missed in your presentation this information, but I was curious at the end about how did you really experiment all these configurations? Did you use any simulator like Mininet Wi-Fi or some similar simulator just to register how these configurations would perform?
We tested against that data from Intel data, and and calculated the distance, for example, from that data using a radius of 5 meters for communication, for example, but not this directly using this in a kind of simulation software or something like that. Just the the purpose of this model and testing and validating the model. But this is a good sorry, I forgot. But it's good to test, as you said. It would be a good future work to do, I guess.
Okay, thank you.
Thank you.
Any other questions? All right, so thank you very much. I think that's the end of the presentation. All right, so we're to the final conclusions for the workshop, and I would ask Claudia to talk a little about the proceeding, and then we're gonna close with a nice announcement.
Thank you, Paulo, for everyone who is here to this final moment. Not only presence, but also in remote mode. We had at the peak 70 people watching simultaneously, both around 35 here and almost 40 from to remotely. So thank you for that. We received a great many of papers for 2 papers. We accepted 20. That's a good sign too. We had a lot of people coming, going, people from the Lithuania, from Japan, from Malaysia, authors from different places. Also a lot from Peru. Saw from Colombia. Saw from Argentina. Thank you very much. A lot of people also from Brazil. Great. And not only from Rio, we have people from Ceará, we have people from São Paulo. Unfortunately, we cannot accept everyone that we wanted to, but it's a good sign. It's a good sign because now we can recommend fusion. About the IPOE proceedings, we're doing right now. We are organizing. We will take off the no-shows. Gladly, just have one no-show in the conference. So we take out the no-shows and we will submit the ready versions to the IEEE to do it with the proceedings. So if you have something that you want to alter in the paper following the format, of course, you can still alter it. If you have found something that you want to change, feel free to alter it. And this will finish our process. Reminding this workshop, it's a standalone workshop. It's part of the ISIF, International Society of Information Fusion, and we are intending to lead you to the Fusion Conference in 2024. One good news, me and Paulo were talking yesterday, we are planning to propose a special session on Fusion 2024 about Latin American fusion. In the very similar format the Latin AI community do. And it's a very interesting thing. This is something very cool that you can try to do next year. And not only to do this workshop in here, but also in the community to show the community there's an interest in that. Also, we are already planning to Fusion 2024. It's a great paper, so thank you for that too. So it's leading to 2025. This sense, thank you very much. It was a fast speed run to make everything possible we're working on such a small amount of time. But thankfully, it was well done. So thank you for the Federal University of Rio de Janeiro for the support. Thank you for the ISIF, International Segmentation Fusion support and sponsorship. Without the sponsorship, some of the things that we were planning would not be possible. I'd like to thank all the authors that present their papers today. I know that some of you had to do a stretch to do it in time. I'd also like to thank the reviewers that have made a great effort of reviewing much more papers that we initially had planned in a very short amount of time. We had like 2 weeks to review all the papers. And I'd like to thank José Brancalhão, our keynote, for being here, and all of you that stay here, even if the menacing storm that is about to come. So, like, thank you very much. So that's it. We would like now to announce a very interesting prize that we have discussed. We had a tough call on deciding which was the best paper of the conference, of the workshop. We in Paulo got like 2 hours on it. Can talk a little bit more?
Yes. So even before I talk about the prize, the award, I want to mention this. The one thing that I've been in the ISIF board of directors for many years now, and one of the priorities is extending the reach of the society. That's one of the reasons we were able to do this initiative of having this workshop, to have the conference in Brazil, and to grow the community. A concern that Professora Maria Claudia mentioned here was the price to us Brazilians and to anyone in Latin America. This has been discussed, a number of initiatives. Claudia already mentioned the Fusion in Rio will be one of the least expensive in history, if not the least expensive of all time. But also, there's a number of other initiatives that we are transforming the sponsorships into scholarships, where we support both the registration, which tends to be a high price, and sometimes also the transportation to different countries. And we are happy to announce that the Best Paper Award will receive a free ride, not a free ride, sorry, a free admission to Fusion 24. That's $1,000 kind of gift. So one problem that we had is to find the best paper among very good papers. So at some point we decided we do not have a best paper, we have 2. And now we don't have money for 2 prizes. Well, we reached out to ISIF and to the organizers of Fusion 2024, and they happily allowed us to pay half of the price for 2 admissions. So that's basically means that we will have 2 Best Paper Awards, each one with a free ticket to Fusion 2024. So with that in mind, let's announce first the runner-up. I mean, that was basically the 3rd place.
So the runner-up
is the first one in, yes. There you go.
And very interesting because you are searching for a good translation for runner-up yesterday, and in Portuguese, the Google Translate gave us vice-campeão. That's not exactly that, but we are okay with that. So for the runner-up, this is wrong. Dun, dun, dun. For the runner-up paper, We have the paper Enhancing Semantic Understanding, Command and Control, an Ontological Approach for Message Enrichment, authored by Flavio Ferreira, Júlio César Duarte, and Maria Claudia Cavalcanti. Thank you. Please, Maria, come receive and take a picture. Pictures are important. Someone take pictures with cell phones, like. Now we have tied 2 papers as the best paper on the conference, and understand like to choose. We have like 5 great papers that were very close in points. So we took a toll yesterday to choose the best paper, and we started several criteria to try to find it to be just and to be fair. But at the end, we could take just 2 papers. Those papers will have a free registration in Fusion 2024, and full papers only, of course. Unfortunately, position papers were out of the scope. So the first best paper of the conference is the paper ESS Technologies Evaluated by Swarm Evolutionary Materialistic, an Information Fusion Concepts Application in Smart Grids, authored by Leonardo Ascioli, Gabriel Leite, Silvia Jimenez Fernandes, Sancho Salcedo Santos, Carla Delgado, and Carolina Marcelino. There. So the authors are not here, but great. So, and the last, the second best paper is on heterogeneous data integration for vessel activity monitoring in territorial waters. Authored by Matheus Emmerich, Carlos Eduardo Barbosa, Madalena Lopes e Silva, Gabriel Martins de Oliveira Costa, and Jano Moreira de Souza also received the best paper from the conference, but this was an online presentation, so they are actually both not here. So me and Paulo will hold the forms, and someone takes a picture and send to the authors for them to, well, they will search with me. So with all this good news about a special session, we will propose a special session in Fusion 2024. We will hold a La Fusion 2024. We will try to make La Fusion into the SBC, into one of the conferences of SBC, to try to bring closer those 2 entities, the IZIF and the Brazilian Computing Society. And now you have a chance to be on Fusion 2004 for free. So we are looking for your support next year. We are looking for your support in this event, and search us. And you have my email if you are interested in being in the tele. Huh? If you are interested in being on the La Fusion Telegram group to receive the news, receive the comments, to exchange information, just send me an email and I'll add you in the group, or send you a link to be in the group. So thank you, everyone. And without further delay, I declare closed this workshop. Thank you very much.
Happy Thanksgiving.
All right.